All right, should be live. Can you let me know if the audio is good? Yeah, had to move things around again. So yeah, hello everyone. It's been a while. Today I'm going to be bringing up Asahi Linux on the new Apple M2 chip. And I was going to prepare some stuff ahead of time, and I didn't have time to do that. So yeah, you're gonna get to see the whole process. Yep, all good. All right. Yep, I know the screen is a standby screen still. All right, let's go. So, oh yeah, I mentioned on Twitter that that I was because this is a laptop, it's not a Mac Mini or something. I need some way to show you the screen as I work. And last time I did this, I have a Blackmagic camera and I was going through an AverMedia HDMI, reasonably nice capture card. I'm not sure if a kernel update or a firmware update broke it. Oh yeah, I should put my pop screen on top of the microphone. There we go. Bit better now. Yeah, I'm not sure if a kernel update or a firmware update on the card broke it, but it doesn't work anymore on any of my machines. I just get URB errors, so I have to debug that someday. And then I tried one of my reasonable but cheap USB 3 HDMI capture cards, the no-name ones. And turns out they don't like the Blackmagic HDMI output and just glitch all over the place. So now I'm using one of these amazing macro silicon, like, $20 cards, like $15, $20 cards, which, as you can see, is kind of potato quality, but, at least the camera is decent, so I guess we'll have to live with that. So, yeah, that's what I got. Anyway, so yeah, I was gonna start working on the chicken bit stuff, and I did not get a chance to do that. So, you're gonna see everything. First thing I'm going to do is make a mini build designed for bring up. So I've got my files here, and so the main thing is we know that booting on a new CPU that is not supported yet is unlikely to work until we set the CPU. We call them chicken bits. Apple calls them tunables. It's basically low-level CPU settings, like CPU core settings, and for things that were broken during design or for things that had to be configured after design and stuff like that. And without that, the CPU is very broken and can only run with the MMUs disabled safely. But with that disabled, there's a very good chance. Actually, I know it's going to work because John already tried it, so I know this is going to work. But I'm going to make it a bit easier because we used to just comment things out. I'm going to add a new define. We are going to create a new target. This is T81. Actually, I don't even remember what chip ID the M2 is. The Apple OS. I am downloading this, and it's not done downloading yet. 12.4. But I'm going to pull out the kernel cache and build manifest from the URL zip file, which is this. And I should be able to do that. So that way we don't have to wait for it to fully download. I haven't updated this machine, by the way. This should be the exact build that is on it from the factory. I just went through first time setup and didn't even connect to the internet. Yeah, T8112, thanks. But I also need the kernel cache anyway, so I'm going to do that. So Mac 14G is definitely going to be that one. Let's pull that out. And you already told me the chip ID, but I'm going to pull out the build manifest anyway because that might have some useful stuff. Where is that? Kernel cache, build my fist in 2.4. Take those. All right. So yes, TAT1 12 we said. So we're gonna need the UART. Oh yeah, I need the device tree for that. Also. So that's going to be firmware of flash device tree T, and what device is this? I'm gonna guess J496 IP just by the numbering, or J413. No, 413 sounds more like it. Yeah, I think. Oh, wait, no, 13 would be the Mac. 493, 293. Yeah, 493 would be the MacBook Pro, I assume, unless Apple is being weird. Yeah. So let's extract that. How do I want to do this? Was it the Apple OS 12.4 firmware all flash device trees? Oh yeah, I need to extract that first. JP.adt. All right, that should work. Hopefully I got this right. So, this will tell me what the UART is. UART 0, 3520. And now there is a sock.conf.h here, I think. Yes. So here's where we need that. And it is the same as the M1. That's great. Thank you, Apple. That makes life easy. Excellent. This is the M2, right? Oh, these are probably set by the system, but it's a max 14.7 anyway, so yeah, definitely that. It has ProRes, so it's obviously yeah, and it has the need and 10 8112, yeah. Just making double sure. Okay, so yes. elif target T8112, early UART base is the same as M1. It's interesting because they did change it on the Pro and the Max, but I guess because that one has sort of a different lineage. I mean, you can tell from the chip IDs, right? It's interesting how the Apple marketing is very different from like the actual technical sort of design lineage of the chips, right? Like the M1 isn't the M1. The M1 is the A14X. It's the tablet version of it's a direct continuation of the tablet line. Then the M1 Pro and the M1 Max are the first actual desktop chips. And sort of if you look at the development timeline, like sort of, you know, you can think of it sort of the fork history, the sort of like device types involved. That's kind of how it goes. And I expect we'll see something different for whatever those AR glasses thing Apple is working on. And maybe a different one for the Mac Pro if they do something crazy. Otherwise, it'll be the same line as the M1 Pro Max and Ultra. Just, you know, the next generation will support more dies or something. Like those are the two directions Apple can go in, basically. No, they'll keep the baseline version of the you know, the low end version for the Macs the same as the tablets, the T81 range. The T6000 will be for the Pro machines, which are the ones that, you know, ostensibly have at least initially had, you know, were sort of proper desktop chips, proper Mac chips, and then the, you know, we don't know what they're going to do for the Mac Pro. It's either going to be just the equivalent of the M1 Ultra but more, or a completely different thing. So we'll see. We'll see, I guess. Yeah, if they just make it so that they can have like more than 2 dies, they can have 4, or their dies are even bigger and have more stuff or something like that. They might just do the same thing they did with the M1 Ultra. But if they do something different with like external RAM and PCIe or sort of like something more like a traditional desktop machine, then I would expect that to be yet another chip lineage. So yeah, I don't know. We'll see. Do we know if this thing supports non-VHE mode? Well, we're gonna find out. All right. So that should be enough for the sock, and now we have. We're gonna do a define bring up. And instead of just commenting things out like this last time, I'm going to actually use this. So we don't strictly need GXF, but do I care about that? No, I don't. We're not going to do... Why is that white? Oh, because I didn't... Okay, that's how the language server does it? Okay, fine. Yeah, so we are not going to initialize almost anything. We do need to kill the watchdog. That's one. We don't want to do the P manager. Not yet, anyway. And we're also not doing any frame buffer stuff yet. Nor clocks, nor CPU freak, we're not doing anything. Basically, in bring up mode. We only want to bring up heap block, maybe get the device info, and the watchdog. That's pretty much it. And then we run actions. That's not going to do anything because there's no next stage. These shutdowns aren't going to do anything because nothing was initialized. MMU shutdown, does that actually do anything if it's actually enabled? Memory. Oh, it does. Okay, yeah, then let's make sure we don't do that. We might as well disable all this anyway. Exception shutdown is fine. NVMe shutdown, that's definitely not going to do anything if it's not enabled. And then in the action stuff here, we do payloads, set active true. I don't think that does anything if it's not initialized. Let me double check. Set active. If active, add dev console kick. Yeah, that's not actually going to do anything. As long as it's not initialized. Because if it let me just double check that I'm sure not breaking this. I might. I mean, to be honest, frame buffer would be fine except for the MMU mapping stuff. But is it unsafe to try GXF? I don't know, but I mean, the thing is, I know I don't need it to get a basic serial shell. So, if I don't screw this up, that'll be the only time I have to flash this until I get the MMU working, and then I'll do another flash and USB, and then I'll do another flash just so I don't have to keep initializing via serial. But I'm trying to minimize the amount of work I'm doing. The only thing I want to check here is the IO depth for this. I think always gets set. I think I might not be checking if this is initialized actually. I do the reinit, but I probably want to actually. Oh yeah, but the reason for that being in there is because of the scroll back. But I do have the IO dev is writable thing, I think. Can write, yes. Yeah, okay, so it does check for that. So it is just going to buffer things for the console, which is fine. So that won't break anything. If not USB up, okay, so this is where we do if and def bring up. So that definitely not using USB. And just in case, this shouldn't actually matter, but make sure we don't do that. All right. So let's build that, see if it breaks. Yeah, I don't care about warnings. And you will probably see that if I build this now... Actually, it is still building on the sources, but a lot of it is not going to get linked in because we're not calling it. So that should work. hopefully that build works. All right, let's install it. I do have a serial port working, so time to reboot this into recovery mode. Die. All right. All right. Can I please increase the font size? It's pretty much as, I mean, ignore the right side. This is, I know this is small. This is pretty much as big as it goes without it like completely killing my productivity. Sorry. Please watch in 1080p if you can. Um, so let's go to settings. As I said, I haven't updated this at all. I'm gonna have to enable the Wi-Fi now in recovery mode. To just copy my file over, though I could use USB if I really wanted to do like a zero network setup. This is kind of bright. This is kind of low, isn't it? Yeah, sorry for the potato quality video. So I'm gonna need some network now. Can I actually turn this on here? Yeah. Let me just get my password in there. Oh. Yeah. Yeah, sorry for it being dim. Again, it's just kind of the potato quality capture card. Can't do too much about that. I tried to adjust the levels a bit, but yeah. I mean, it is a dim screen also. Like, it's kind of grayish right now. I think you can't even change the brightness. The touch bar is off in recovery mode, so. All right. So I need to curl this. Uh, so we first kill all the security. There we go. And now. Okay, that works. And I keep forgetting the kmutil magic arguments for the git Asahi installer. Where is that? This step 2 stuff will have that. Yeah, these. Configure boot. C, yeah. And then we need raw. Entry point 2048. Lowest virtual address 0. And the All right, so let's see if it works. This is going to be UART only, so I do not expect to see anything there. Picocom, PTS, what is this? 14, I think I ended up at. 31, apparently. I'm going to reboot now because I probably missed whatever log that was. Let's see if it works. Oh, that didn't. Is that not work? Hold on. Hold on, my USB PD interface is being silly. Hold on a second. Is it gonna work now? Yeah. I don't know what happened there. Okay, now it's rebooting. Let's see if it works. Yay, it's alive. Cool. All right. So we're good. It runs. That was easy. First try. All right. So I can kill that. What was this? PTS 31? And there we go. It's alive. So someone wanted to know about the VHC being forced on. Let's find out real quick. That's easy enough. Whoa, that really didn't work. Oh, because no MMU, so yeah, that doesn't work. I need to like fix that somehow. I need to do something so it doesn't try to do that. Yeah, that would be nice to fix, wouldn't it? Let's what's the best way to do that? Because I need to find out if the MMU is on or off, but there's no obvious way of doing. I mean, I could just check in the init or something, but I don't really have a good init function. Whatever. It's fine. Hello. Oh, yeah, my USB PD interface is being silly today. I don't like that. It's gonna be a bit annoying. All right, because the baud rate switch, and because I unplugged it and plugged it back in. Yeah, that's fine. Okay, there we go. So that works. Yeah, I need to. I don't just work around that. In proxy utils. Let's just add a thing to this. And just make it let's say MMU off. And then in call, I'll just say if, just kill that. Do that again. Okay, yeah, that works. And what is that? How is that done? How do I call those things? Sysreg. Oh, just ACR. Sorry, yeah. So this has E2H equals 1. And that is that bit. Turn it off. Yeah, that's still forced on. So still no non-VHE mode in this one. All right. So next thing, let's see how much stuff we can turn on before it explodes. So that bring up define obviously works. We can get rid of it now. And USB is going to need those lovely new darts, isn't it? But first we need to do the chickens. So we can turn the MMU on. So what I'm going to do now is what I'm actually just going to be commenting things out. I might as well let it try to initialize everything else, and we can see where it explodes. A lot of things are just not going to be, supported, which is fine. I fully expect USB to break. But we'll see what breaks and how it breaks. But the first thing is going to be the chickens. So let's do that. I've got the kernel, and I'm going to do where was I? Somewhere here. Where was my? I think I closed that. So let's go and and just make a temporary place to dump stuff in. There. Can't type today. This should be 12.4. Kernel cache Mac 14G. I'm going to do something really dumb. Because for figuring this out, we don't even need Ghidra or a real disassembler or anything else. I don't even need something that supports Mako. I can just dump this file. Well, I do need to extract it. But like the sequence I'm looking for is literally just a big pile of instructions in line. There's no like function calls or anything, so I can literally just do how was that? Something like that. Was it a binary? I think I need some options for that, but I need the target, I think. Yeah, B binary, and the architecture is set with -m. ARM v 8.1, ARM v8A, I think. Yeah. No. That was a bit weird. That doesn't look like real code. Unless it's like data sections. No, that doesn't make sense for a kernel. Oh, sorry. Not the compressed one. No, this isn't the right architecture. I see. It's not ARM-v8. What am I doing? ARch64, sorry. There, still not quite there. Unless this is just the data section, which it could be. Okay, that looks like code. Yeah, it's fine. It's working. Let's let that finish. And then we'll search for one of the HID registers, which will quickly find that sequence. So in CPU regs.h, we have these. They are definitely going to be touching some of these. You can just search for this whole S3015 section, and it'll find it. Yep. So we want S3, 0, C15. That's not it. Yeah, that's more like it. Yeah, this is one of those. But it's not quite as long as I expected. Is this it? It might be. DPIDR. This might be one of the sleep sequences, though. No, it's not. It is doing stuff. Yeah. I think that was it, yeah. It's possible that because this is the M2 kernel, it has a much shorter sequence than the... Because the M1 kernel has like a pile of variants for the M1 Pro Max and all that. And even like different steppings and things like that. I think this one might just not have that. So I think that was it, yeah. Because the other kernels had a lot more code in there, but... And also, the M1 Pro Max kernel also had the M1 chicken bits in there, but I'm guessing this one is actually, yeah, really only has M2. So that's the sequence. And I'm just going to copy and paste it. Just going to dump it in a file here. Yeah, let's look at it, MPIDR. AP8660. Yep. And at the end there, 8C. I think that's pretty much the end of it. Let's get a bit extra just in case. So yeah, this is going to be probably the only disassembling we're going to be doing today, because this is the one thing that we need to grab from macOS, because we have a chicken and egg problem. We could infer this by running macOS in the hypervisor, but the hypervisor is not going to work until we get this running. So yeah, these are just CPU settings that need to happen for the CPU to like not be broken. So obviously we don't copy the code as is, but we have to look at it to figure out what bits Apple is setting. Actually, let's put it back in here. Yeah. And I think I had a thing for that. Get many tools. Reg filter, yes. That. And I need the reg file, which is Apple regs. And then it's just standard, yeah. Chickens. Chickens txt. It's 2. And now, if I'm right, yes, we get the names, so that's good. Makes life a lot easier. So the other thing I want to do also is because I also let's make this do constants. So let's do B0x09AF. B hex hex parse line, and then we can do def hex parse m and VM group 0 int m group 0. And let's make the hex constants a bit nicer here. So if v and v minus 1 equals 0, that means that's a single bit set. So in that case, let's get the log2 of that. Return bit. E and v minus 1 equals 0. Yeah. How do I detect a consecutive sequence of bits? That's a bit annoying. But I think there's not that many of those. The one thing I want to do is So yeah, that should give me some nice hex constants if I write math. Int, yeah, I need that. Math domain error. Oh. And is not 0. Yes. So hopefully that'll make it a bit easier to look at those. Or not. That did not work. Oh, some of them worked. And some of them didn't. Oh, is it because of the end of the line? No. What? What am I doing wrong? Hold on. Chickens. It's just not regexing. Why is that not matching? 0x 09AF. Is it the B? Oh, wait. No, it is raw. Sorry. Oh, sorry. Plus. That was dumb. Yeah, there we go. That's more like it. Yeah, so this is a lot more readable now. There's a few that have masks. I'll compute those manually, but everything else is a lot more readable, so that's good. All right, so now let's put this into Mini. Well, let's clean it up first a little bit. Might as well just kind of type stuff in here, right? So we're checking first. We need to know what machine ID. This should have two segments. They should have one for the E cores and one for the P cores. This is checking for that. This is checking for P cores versus E cores. And then this is checking these specific chip IDs. So let's go to the chickens file in Mini. So this is what it looks like in C once we finish cleaning it up, right? So as we can see here, the parts that we're interested in are 31 and 33. And these were called Avalanche and Blizzard, right? I am assuming the naming is in the same order. We'll check. We'll see in a second once we see the P core versus E core. Actually, I can just check with Mini. Because it should be booting on the E cores. Is it EL1? Oh yeah, I forgot about that. Sorry. You decided to no MMU mode. I should make it pick that up automatically. Do I have any init stuff? I think. Utils. Like I don't want to introduce spurious commands in the. Oh, and it went back to macros. That's the other problem. This is going to annoy me until I get the PMU reset working, which actually should be pretty easy. So let's do that pretty soon. But yeah. That's That's another thing. Actually, it should already work. I think. Let's see. Let's see if it just works. But that might break. I really shouldn't. It's just gonna be slow getting the ADT. Um. All right, the cache there. And the and that. I keep doing that. Okay. Is that gonna work? Let's try it. It's just be a bit slow because of the ADT, but oh, okay. So that's interesting. Where did I put the ADT for this? Why are those arrays and not arrays in this one? Is it just because I have compatibles set for this? SPMI star. It's not SPMI 0. Wasn't it? Oh, yeah, no, it is SPMI PMU. Oh, PMU main is what it got called. Well, that's funny. Okay. Yeah, okay. Apple just changed the name because for no reason, I guess. It just says star PMU star. Yeah, that's more like it. SPMI Gen 2. Maybe the interface is different, so if so, that is not gonna work. I think that did not work. Yeah, that did not work. So SPMI is different. That is unfortunate. That means that we're not gonna be able to make this work until macOS works, so I can get a hypervisor trace. So I'll have to live with those stupid fallbacks into recovery mode, unfortunately. Oh well. All right. So there's one driver that I was not expecting to have to write again. Um, that goes on the list of things to do. Thankfully, SPMI should be pretty simple. So unless Apple did something completely insane, which would not be out of character for them, that shouldn't take very long to figure out. All right. So where was I? Yes, the chickens. Actually, give me 1 second. I'll be right back. I should be back. Yeah. So let's see what they're doing here. I was going to check before I got sidetracked again. Wait, it just rebooted. Why did it just reboot? Is the watchdog disable not working? It claims to be. Oh, maybe I fucked up the PMU. Maybe the SPMI stuff I did broke something, and then SMC crashed. And when SMC crashes, oh, that's another very, very interesting question. Once we get there, not yet there yet, but I'm very curious as to whether Apple is moving more of this functionality into SMC because they really should be. But we'll see when we run the hypervisor. And we're back at that. I don't know why it does that. Yeah, I did catch it this time. Yeah, there's some issue with the USB PD interface where it gets stuck into that like retry fail loop, and it's just flaky. But anyway, we'll get past that pretty soon, hopefully. Yes. So I was gonna get MIDR. But I want to see if proxy utils. Oh, it does read boot arc, so yeah, we can afford to do that. It's just that running code with MRS. Yeah, no, we should be using a proper proxy code for this, not just running code because that runs into the. I guess I can run it as. No, I think I do need that. Yeah, if it's not enabled. So, yeah, no, I'll have to add a proxy code for that or something. Let's not do that now. Because I don't think there's any way of finding out if UMMU is enabled other than a sysrig, and we don't have a way of safely using that without knowing. So, MMRS kills it with the MMU off because it's trying to use a MMU mapping. Because with the MMU on, we can't run and execute code from the same mapping. So I have a flag to turn it off. It's just that I need to remember to do that. So yes, this is 32. So hopefully 32. Oh wait. Hold on. So we have two of them. It looks like. So that's probably then T8110, the A15 or whatever. Yeah. Pretty sure then, yeah. I'm just gonna guess that. So this is 32, which is backwards. Because Blizzard is the P core, right? Oh, efficiency is Blizzard. That's correct then. But in the previous course, we had Ice Storm before Firestorm, so that's kind of backwards, but okay. Assuming this is booting. Yes. So this is on the E-cores, and those are 32 apparently, so that's interesting. So let's split this up into sections. MPIDR, this is a bunch of non-zero. Yeah, so this is the E1. We knew that. So the first thing it does is that with the E hit 4. Which I think we already know about. So that one is CPU regs. Because hit 4 seems to always be the same so far. So there we have bit 11. Yes, disable DC MVA. And disable DC S32L2 ops. So those we already have. And that one. Let me move this a bit. Yeah, so we do this unconditionally anyway, so that's fine. No problem there. So we can just ignore that. Then this is the actual like sort of per core chicken bit sequence. So MIDR EL1, MPIDR EL1, it checks whether it's 0 means E core equals 7C. So this is E core. Otherwise, this is P core. Actually, no, this is P core only. If P core do that, that's interesting because it hasn't even checked the CPU ID yet. Then we have and if not, then it says if E core 8B98. So that goes on E cores. And then it's checking the ID if for 33 and 31, which is the same thing anyway. If avalanche. And then we have if T8110. Okay, compare 31, not equal there. Go here. And then we have... Oh, wait, no. 30? Okay, no, then I got these offsets. Sorry, that makes more sense. So Blizzard is 30. Yeah, okay, that makes more sense. That's why. Yeah, that makes more sense. So this is checking for T8112 avalanche. No, 10 avalanche. 31, yes. This is checking for if T8110 Blizzard, sorry. If T8112 And then we have 33 E12 avalanche. And then we have... Oh, this is different. Yeah. If... Oh, wait. No, yeah, branch not equal. Why is this done like that? That doesn't make any sense. Why is the logic done like with two branches there? If T112 Blizzard, and then we have 31 T110 Avalanche. If 33 T12 Avalanche. Hopefully I'm getting the names right. And this might be the end of it, yeah. And this is just AMX stuff. We don't care about that. This is that ID thing we already do. That's not part of chickens. It's this. Yeah, this is the same thing we're doing here, basically. Yeah. This is whatever that is the same. The interrupts thing, C15, C10, 4. They only do it on T6000X, but as long as it works on these, I don't care. Might as well do it. Actually, let's just try it to make sure that it doesn't break. Yeah, it doesn't break. That's fine. And the psych override, I believe this is the same thing we do. This hasn't changed in forever. And the rest of it we don't care about. So yes, that's all the same. So just these nice chicken sequences. Let me make sure that let's double check to make sure I didn't screw this up. So that is checking bit 16. If it's 0, it skips. So that's FP core. It does that FP core. That's checking that. If it's not 0, it skips. That's FE core. Then we have 31 or 33. Which is avalanche. Then we have 31, which is 8110 avalanche. Then we have 30, which is 8110 blizzard. 32, which is 8112 blizzard. Oh, that should be like that. 33, which is T8112 avalanche. Then 32, which is T8112 blizzard. 31, which is T110 avalanche. And 33, which is 12 avalanche. Yeah, that's good. And this is the stuff we already know about, so get rid of that. All right, so now let's translate these into something saner. Some of these are going to be the same. So let's look at this now. Convert bits to things we already know about, because some of these have not changed. So HID 1, oh, bit field insert. That one looks new. E hit 0 is also new. Okay, yeah, then these are all different. One question is whether they're actually going to ever overlap between different cores. So unfortunately, we're not going to have any names for these because all the names we have for these came from Apple's previous source code dump, which actually had the source code for these chicken bit sequences for older cores. But any new bits that we haven't documented in the wiki page, we just don't know. So hit 0, for example, at 42. Yeah, we don't know what that field is. I am reading this right, am I? Bit field insert, like start bit and bit count, hopefully. You just check the instruction. Yeah, LSB and width. See, that's a lot easier to read than Earl Winham and Earl Wimmy. PowerPC reference. Yeah, that's fine. Yeah, see that's a very sane way of doing bit fields. So we don't know what this is. Let's this is hid 1, 42 and 22. Hid 1. Yeah. Yeah, we don't have that. Actually, wait, 22 2 bits. Oh, okay, so that's already overlapping some other thing. That Yeah, okay, so this might actually be stuff that they do not they don't care about keeping the bits non-overlapping between different CPU generations, which is fine. I know hit 4 stays the same because that one they use in multiple places, but it looks like hit 1 is not stable. So in that case, yeah, we just don't know. Hit 1. I don't want to have long names for the cores, so I do wonder about things like Trap SMC though. Like that one, you'd think it would stay from core to core because that's the kind of thing that, you know, they'd want to use. And I do believe do they ever set that one from hit 1? Oh, they don't. Interesting. So maybe that's in a different place now, or who knows. Yeah. So basically, this is doing hit 1. What are we calling these? P cores are avalanche. Was it? Yeah. Let's call it. Let's use 3-letter names. Unc 42. And this would be 4342. So we're going to need those. And then it's taking hit 11. That one we do have. The LDNT widget. So that one seems to have stayed the same. So let me start writing down the chicken sequence here, and then we'll just kind of I was doing these with mask and gen mask, and then I was just using not field prep, but just macros like this, which is okay. Might as well just keep doing it like that. For these at least. Mask, and these are 2 bits each. And yeah, so let's do this hit limit one has been unchanged. Where am I? Need to close some stuff here. So what we have is hit 1, mask. We're doing first bit 42, and the order usually doesn't matter, by the way. And just sets that to 0. Wait, no, bit 0. Sorry, that should be 1. Oh, I should not. Yeah, well, that's fine. Sets this to 3 for 22. Then it sets the disable LDNT widget thing. These are hit 1, sorry. Then on the E course, E hit 0, bit 32. Do we have that one? We don't even have it E hit 0. We do, but it's bit, yeah, we know that bit. Am I doing the E's consecutively here? Yeah, I am. That's, the E's were just 3, 0, 15, 9. No. Yes, the 1 at the end means E. Except for some weird cases. Blizzard, and, yeah, we don't know what this is. That one is like that. Then, Avalanche. This is always one of the fun ones. They do a ton of stuff here. Their peak cores are always questionable. All right. So for all the avalanches, it's doing hit 9, bit 26. That one we do have. Hit 9, bit 17. We don't have that one here. Is it here? No. It's just above TSO enable, though, so I wonder what that's about. But TSO enable moved to the main register anyway, so. Whoa, what just happened there? It's 17. Then it inserts 4-bit field in hit 13. That one we do know, it's reset cycle count. Um, 60. Now we don't know if that's the same though, but. Because then we have 50 there too. But might be. Oh, there's a lot of them there actually. That might not be reset title count then because it might be though some other cycle count. I guess this is some kind of cycle count register, but I don't know if that one is accurate for this core. But so we have 50, 46. They're all 4 bits. That's a lot of inserts, and also it's 7. There's 7 bits. Uh, 13, 7. And then we have 14, 4. 14. 26. 30. 34. 38. 42, 46, 50, 60. Yeah, 17, 14, 26, 29, 33, 37, 41, 45, 49. I think that's right. So what we actually have here, and we're going to write this differently, is because as I said, the goal isn't to literally copy the exact same operations that Apple does, is to just make the same changes. So, expressing this sort of nicely, we have 50. Actually, we have a 6. This is 60. Yeah, 60, which is the cycle count. 0. Then we have bit 2, which is 4. Four, 30, 26, and 14. I'm just going to start deleting things because I'm pretty sure these are right. So we have reset count 0. At 50, we have a 4. They're all 4, actually. All 4 until this one, until 26. So that's actually correct. I copy paste. Then we have for 14, that's 1. Reset cycle count was correct, right? 50, 61. Yeah, it is 0, yes. Making sure it was 0, not bit 0. 14 is 1, and then we have 7 gets bit 3, which is 8. Oh, and then there's... Wait, what is BF exil? Isn't that the same as BFI? Yeah, it's just because I guess in that case it optimizes to that. It just means the low 7 bits. So we have at 14 1, at 7 8, and at 0 also 8. And that's a big chunk of the Avalanche stuff. Okay, so the way we actually write that is reg mask, hit 13, and let's, I guess, write them as in order. Plank format is going to format this anyway, so. All right. That was good. What is this? That's a new one. Three zero 1503. That sounds like another HID because they ran out of numbers. Because they started doing this, right? And then it was like 15, 15, 2, 15. Yeah, I have no idea what that is. Does Google know about this register? Some Cortex thing? Yeah, no, I don't think so. Oh, AVL50 mask is wrong. It is, thank you. And I might as well do that. Oh wait, hold on. What? Isn't pre-cycles the one that we already had? Pre-cycles is that one. Hold on. Yeah, 14 we do have. Sorry, I'm dumb. So it is changing reset and pre-cycles. Yeah. Wait. I need to sort these again, but yeah, I want to sort these by LSB to MSB. Just be a bit annoying. 8. Sorry, 0, 7 pre-cycles. 26, 30, 34, 38, 42, 46, 50, and reset cycle count. Yeah, so I don't know what this one is. So that one is 36. 8 bits, so then we have 1A at 0 on the same register. Forty-three, 36, and 0, 8. So and then we have this one, which is 1F at 8. Right, that takes care of that. Hopefully. Anyone would wonder if someone at Apple is watching these videos, screaming at their screen, you're doing it wrong. I mean, we know Apple employees watch some of these videos because sometimes they are in the chat. So, so hit 10 EL1. Do we have that? Bit 49, 34, and 33. Yay! 39, 49 we don't know about. Wait, no, that's wrong register. Hit 10, 49. Yes, okay, no, that is right. That's reg set. That one. And then we have 21. Do you have any of those? 33 and 34 we do know. So let's call those define, hit 21. Let's go. Yeah, that's a ridiculous name. That's a ridiculous name. I'm guessing on the expansion, expansion of trans there and compile, but I think so. And then we're setting those on 21. Okay, and that's the end of this avalanche section, which is a good part of it, so that's good. We can get rid of these assembly snippets. Simplifying things. Mind you, we're not going to necessarily support the TD110, but E hit 10. Do we have E hit 10? Do we have anything for it? Yes, this is bit 49. We do have that. It's the same one. Didn't we have that? Yeah. Oh, we do have. Oh, wait. Oh, we have 49 for E hit 10. And we also caught it here. Okay, so I guess E hit 10 and hit 10 probably have the same bit for that, I'm guessing. Oh, I think we actually... no, we don't. Yes, we do hit it. Yes. So those are... Yeah, those are shared between E hit and... Oh, no, we just never did hit 10. We always... we only had E hit 10, but they are the same bits probably because they do the same... They look the same. They're kind of... They feel like they were using the same bits there. So that would be... Ooh, what's the... 10... Yeah, 10-1. So that's the same then. Then if T8112 Blizzard E hit 9. We don't have that one. Yep, that one is new at bit 6. And now it's 6 bits at 6, so 11-6. At least it's consecutive with that one, so that's good. It means it might be safe to put this as a generic one. And then it does set bit 5, which we do know about, so that is probably okay. So I guess for mask, we might as well do these separately. Mask. 6. And then that one is 3C. And then we just do a reg set of E hit 9. And that one is bit 5, which is that throttle to enable. That takes care of that block. And then 8112 Avalanche, I bet some of that is going to be similar to 8110 Avalanche. Getting there. Oh, there's another 3C here, look. Well, that sure looks like it's the same thing. Hit 3, bit 57. Interesting. So that's probably the same thing, but we still don't know what it is. Hit 3. It's bit 57. Unc 57. Again, mask. 6 bits at that, so 62. Yeah, that makes sense. Still lines up. Mask. Hit 3, Apple, unknown, 57. 57. 63 we do know about. AVL, unknown, 57. Here's a fun one, reg set. Like PCIe throttle enable, right? Like, why does the CPU core have to know about PCIe? Like, I do suspect that Apple is doing some like very tightly coupled memory system stuff that forwards knowledge about specific memory regions, like all the way to the CPU cores. But it's just interesting that you see like PCIe mentioned in a CPU system register. There's actually something to be said here. Some of these registers might be cluster global, and an easy way of finding out would be to just run this on different cores on the same cluster and seeing if changing it on one changes it on the other. So that'd be an interesting experiment to run. So 63 on hit 3, and then we have hit 18. That is unknown. So we need on 18, bit 27. That's just a bit. And bit 29. Both of those get set. I think everything has been set so far. I haven't seen any clears, unless I missed something. I'll look at the original after this, but and then hit 16, bit 12, which we also don't know about. Yep. And 12. All right, that takes care of that. And then on Blizzard, that's another unknown one. 301511. Wait. Oh, yeah. Yeah, we don't know that. It's another weird offset one there. Can I guess? 11.2, 11.3. That's E-hit 18, isn't it? Because this is Blizzard. Okay, yeah, that's E-hit 18, which makes sense because this was hit 18. Okay, I'm going to go with that one. I'm assuming that one's correct. E-hit 18, bit 34, which you don't know about. Yeah. E hit 18, bit 34. I should add that to my register list too. Hit 18, E hit 18. Like sometimes you can guess them like this, right? All right. Back to CPU. Sorry, CPU regs. AVL S0 mask. Blizz, not AVL. Yeah, good point. I'll use BLZ. I'm gonna use three-letter names because otherwise it just gets too long. And also Apple does like Psych and stuff like that for Cyclone, so it seems to be a pattern they've also used. TD110 Avalanche. Here's what's going on here. Oh, this is just the this is just the check. Hey, what's going on here? Oh, this is a revision check. Uh Yeah, that's the thing with the revision being split into little chunks. And then yeah, so this is just checking for bit 4 if revision not and be my, I always forget what that is. Minus. I always forget the logic for that. Is that what it is? I always forget the compares. No, you hit 9 to use BLZ. Oh yeah. Good point. Yeah, I always forget how the how the ARM comparison logic is compared with 8. Let's just write 8 here before I get confused. No, not 8, 16. I'm dumb. 16. Yeah. So if the revision is less than 16, skip. So if it's great, isn't that just a greater than equal? I think. Yeah, branch on minus, branch on plus. So that's only going to be minus if it's less than that. Yeah, I think that's what that is. So these are probably bits they added and were not supported in the older revisions. Hit 21, we don't even have any of those. Hit 18, we do have. That's bit 39. That's probably a spare bit, which means this is a silicon hotfix, which makes sense. I'm going to call that spare bit 7 just because they're in order. And just take a guess on that. Because that sounds like a hotfix. The spare bits are literally that. Like spare bits they leave in so that if they have to patch the silicon, they can do it, and they already have registered bits allocated for it. So I'm just gonna assume they are actually in sequence, and that would make that spare bit 7. So that one is hit 18. And that one doesn't need AVL because it's kind of a generic name. But the hit 21, that's probably also a spare bit, but do we have any of those? Hit 21. Bit 52. Yeah, we don't have that. We don't even have... Oh, no, we do have hit 21. Sorry. Yeah, we do have 21, but we don't know what it is. So we can just call that one AVL... Unc... 52. Okay, and just the last bit then. T8112 Avalanche. That's another revision check. Branch if not equal to 0. Yeah, so that's easy. If it's not the original revision, then we get hit 7. And that one is, first it sets bit 16, which we do have. Reg set. Hit 7. We're going to get the sys out for later, but. And those don't even use the EL1 suffixes. I should fix that at some point. So that sets that one, bit 16. And then it clears. No, it sets a hit 7 mask. How many bits is that? 24. We don't have that. So hit 9. No, not hit 9. Hit 7. Oh no, we do have that. That's this one. And bit 20 is not getting set. And that is a bit. That's a 3. I think this is a fix-up they also did on M1. So you can see, right, how they're developing these chips in parallel. So if we compare this to M1, you'll probably see how like this hotfix was probably applied to a later revision of M1, which means like they were getting taped out at about the same time, or like, you know, the first sort of validation tape out of this was missing this fix up. I wonder if this is actually like one of those like speculation vulnerability fixes. That would kind of make sense. So yeah, if you go to chickens, right, and look for this. So that's always used in Firestorm, which is interesting then. Why? But it looks like that was missing in. Oh, yeah, but that one only has both of those bits though. So that's interesting then that this one only got that added after Rev 0. I did get a check right of that, right? If not oh, sorry, branch if not equal. Sorry, if Rev equals 0, then sorry. I did get the logic there wrong. Okay, that makes sense. So that's yeah, so that makes sense. So I think what happened then is that they added this bit to fix something. They've had it in Firestorm, and then they got rid of it because they they hard coded it or something after that revision. They just decided that, you know, like they would bake this in, or that is disabling something that is broken, and after that revision it was no longer broken, right? So they were always that maybe this is an actual chicken bit, right? Because it says force non spec. So maybe this is a chicken bit to fix a corner case that was not handled properly. And that's broken in all M1 Firestorms, and they fixed it in anything greater than revision 0 of Avalanche. So that's why there's this revision check there, right? So you can see there then, yeah, sort of how the timeline works, right? All right, that's the end of it. So I'm going to save that. Let's put it into the C file and clean it up. This might... I might want to put these into different files, because now it's getting a little bit... I don't think we share anything between Ice Storm and Firestorm. Yes, let's split these up into several files so we don't kind of make a big mess of it. Um, do we really need header files for these? I mean, it's kind of silly. Because we only call these from a common place anyway. So Firestorm has separate ones, and then Ice Storm is the same. Those even have the revision passed now. And again, we also only need the revisions here. So let's do M2 Avalanche. Sorry, Blizzard. I'm just sort of guessing here, but and yeah, we're not going to even support the T8101s. We don't do those anywhere. So I mean, I figured those bits out, and I'll keep the file around, but I'm not going to commit that at least until someone has a good reason to support, chips that this won't run on until someone finds an exploit. So, yes. So let's move those around. Ice Storm. These aren't static anymore. Don't need chickens. And now we have Avalanche and Blizzard. So, Blizzard first. Let's get the headers in. Actually, going to copy this around just in case there's some similarity that I can reuse. So for common, we have first that eCore one. And then in T110, we're not doing that one. T12 Blizzard, we are doing this one. Oh, interesting. E hit 9 gets cleared in. This was a set, right? Let me double check. Make sure I don't overwrite that. Let's triple check that. E hit 9 EL1 has, yeah, bit 5 set. Wait. Interesting. Yeah, okay, so that gets set. So that's different from M1, unless I got that wrong, but I think I got it right. So yeah, so basically for E-cores, and that's it. There's no if Blizzard, so that's the only thing on the common one. And then in M2 Blizzard, we do these two. And that's it, right? No, we also have another one here. That's it. What error do I have here? Viz unknown 6. Is that missing from something? No, it's in there. Oh wait, hit C. What? Did I? That should be 18, right? Wait, what just happened there? That one's broken. That's wrong. Yeah, T12 Blizzard. Yeah, 32. Which is, yes, it is that. Or bit 34 of E hit 18. Yeah, it's that one, so I don't know where that came from. Yeah, 34 of E hit 18. I think that was just copy paste fail. Not sure what's. Oh no, yeah, I don't know what the language server is complaining there. Okay. Avalanche Blizzard. All right, now Avalanche left. Also just gonna steal some of Firestorm for that. Come on, Avalanche. Blizzard. Avalanche, yeah. And we don't actually know how this splits up between M2 and um, T8112 because we don't have M2 Pro and Max yet. But I'm just gonna guess that at least the ones that depend on revision are definitely T8112 because those were obviously chip specific. So we'll just guess and fix things up when the Pro and Max come out. So, first thing it does is these. And then we set hit 9 TSO. Yeah, we do set this one. And whatever that one is. And then we have that fun hit 13 thing. Which one of them at least has that comment in the old one, but I don't know if at least part of that might be related. And then we have this crazy new stuff that we have no idea what it is. Wait, was this the same one? No, it's two of them, yeah. Okay, that should take care of that. Common avalanche. Yes. And then the M2 avalanche. Yeah, so this split is probably the same thing we want, right? So let's just guess that these are the ones from the M2. And then the T8102, T112 would be these two sections here, right? So if rep is greater than 10, I have to putting them in order always, on low to high. And then if rev is equal to 0, mind you, I think we had some like rev 0 stuff that I didn't even copy for M1 because I think the conclusion is that those are like engineering sample chips, and honestly, I don't care if we support those or not. But at least these bits are used in the other ones anyway, so I'm not too worried if about this particular one. But yeah, probably nobody has that revision. I doubt this one is that one. Yeah. Oh. Oh, I do have this. Yeah. What bit was that? I think it's these two. Wait, hold on. Do I actually have 0? Chicken C. Rev low is bit 0. Yeah, rev high is bit 20. Yeah, that's 1. So I have revision 10. So I'm pretty sure nobody has this. It's probably just for engineering samples. And I think I ignored those in my previous chickens everywhere. I don't think I have anywhere where it's like if rev is less than 10. Yeah. I think I saw that in the original sequences. and just sort of concluded that we don't need those. So I think we can just drop that. I don't think anyone's ever seen a revision 0. Heck, wouldn't surprise me if that's like, like simulator or something like that. The revision is not related to the chip ID. So the revision follows a different pattern for each specific piece of silicon, which is why all of these revision checks are in specific SOC functions. So, like, I think what happens is that, so they have like a master branch of the core, right, or something, and they, whenever they start designing a new chip, they'll basically branch that, make a branch for that chip, and then sort of whatever state that was in, whatever merging whatever fixes they are for the first tape out, that becomes revision 0, and then when they fix things up, they backport those fixes and increment the revision numbers separately for each SOC, right? So you can tell because if you look at Firestorm, for example, so we have the M1, right? And the M1 has this fix up in revision 10 and greater. That hit for enable FSR style load pipe to issue. That was also in revision 10 and later for the M1 Pro. But the M1 Max apparently got forked off later because that is unconditional in the M1 Max. So that was already merged into the original tape out of the M1 Max, but not Pro, even though they're very similar chips. And then there's this fixed bug in an actual radar number, which is hilarious. That was added in revision 10 of the M1, but both Pro and Max already had that from the get-go. And then this other fix also was added in revision 10 of the original M1, but Pro and Max also always had that. And then this ECO, MDSB stall pipeline ECO, that was added only in revision 11 of the M1, which means it was a hot fix for that specific revision. I don't know if they ever made any newer revisions, though. They did, because, well, I'm not sure. They might have not have. And then that was also added in revision 10 of M1 Pro, but that was always there in M1 Max. And then this branch kill limit was added in 11 of M1 and 10 of M1 Pro and 10 of M1 Max. So that came later and didn't make it the original cut into M1 Max. And then this spare bit is a hotfix for revision 11 and greater of M1, and 10 and greater of Pro, and 10 and greater of M1 Max. So, like, by reading this mapping to the different revisions, you can see how, like, these fixes were introduced in different revisions on the different variants of the same core for different SOCs. But right now we only have one. Well, we have the 8110. We don't care about that. So basically, when the M2 Pro and Max come out, that might require some refactoring here to move things around these functions, depending on what's common and what isn't. But there you go. This is basically what we have right now. All right. So with that done, let's hold on. Yeah, Firestone. Why did I sort them like that? I don't know why I sorted them like that. All right, let's see if it works. I need to fix the makefile to add all these things. Normally these are alphabetical, though. T8112 Avalanche has bits from... did I forget to clear that? Does it? Oh, wait. No, it's right, isn't it? What bits? I'm confused. What? I think these are just they're these, right? Oh wait, this is 10. Sorry, you're right. Yeah, sorry, I got confused. Thanks. Okay, yeah. So this one only has the Rev 0 stuff. Which means we don't actually need anything. Assuming like those don't like yeah. Yeah. Good point. Thanks for catching that. So in that case, yeah, we don't actually need anything specific to the revisions of the T112 Avalanche. Yeah, it looks like it. So we'll just leave it like that. I'll keep the same pattern because I expect that M1 Pro and Max will need that. Or they might even add more chicken bits in newer macOS versions. That would not be unheard of. I think when I did M1 Pro and Max, I noticed that we were missing some stuff for M1. So it's likely that when M1 2 Pro and Max come out, I'll like redo that and find new bits for M2, which might fix some bugs for us. But they shipped this macOS version, so clearly it's not completely broken at least. Yeah. All right. Is this going to build? It's not a prototype. Void and wait. Oh yeah, that's fine. Unused parameter rev, yes. Using that one yet. And we are missing something. Apple hit 3, hit 18, EL1. Missing those? Oh yes. Oh no, EL1 is why. Yeah. Yeah, it's more like it. And Blizzard. X undeclared. E hit 9. Yeah. Well, that's what I was missing here. The X definition. Okay, there we go. That builds now. Maybe format that. Nice. Yeah, that makes more sense. These are probably related. Okay. So, with this, hopefully, it will. I know USB is not going to work, but at least it should. The MMU should work. The screen should work. A lot of things should just work with this. Let's see what happens. Oh yeah, I do want to drop the logos though because that's going to. Yeah, I have this like config H stuff, but the logos are kind of well. You know what? Yeah, they're still kind of large. Like uploading a megabyte of a serial takes a few seconds. Um, but I don't know how much smaller it gets if I do this. It doesn't change. um, yeah, I think. Actually, how much smaller does it get if I use it? Oh, a lot smaller. All right, let's make sure chain load actually does that. I don't remember if it does that, but it really should if it doesn't. Compress, it does compress, yes. Okay, cool. That's not gonna be that bad then. That's only about a second, so I don't even care about enable FP anymore. So I do, yes, tools, make sure you got that. Is it gonna work? R. Yeah, the ADT, fetching the ADT is gonna be longer than, yeah. And pushing it again. Oh, unhandled exception. Interesting. So the MMU exploded. Did that reboot properly though? No. Well, that's interesting. Reboot didn't work. Is the watchdog stuff broken? Let's see what we did get though. Yeah, something that stuff is broken. That's fine. M2 Blizzard. That's fine. At least that didn't break. The memory base is where I expected for M1, which is interesting because it means they still didn't. They haven't kept the new memory layout from M1 Pro and Max. I was kind of wondering if they would, but no. So that means that M2 is still using a smaller address space, physical address space. So what happened here? Data abort. On a yeah, okay. That's just broken. Um. Hmm. Oh, okay. The MCC stuff is different, right? So the the TZ stuff is different on this one. Okay, I'll be right back. But should be easy to fix this one. All right. So yeah, I think this is just because it's not initial. I think this is just a null, effectively a null deref because the MCC stuff did not get initialized. Yeah. So first, let's oh no, we do have that. Sorry. I just need to check for that. Just need that. So at least that'll stop it from exploding, but let's also make it work. So then I'm just gonna guess this is the same as M1. It sounds like it's like the same as M1. Looking at the ADT will tell us. MCC T8112. Because they use a very different MCC binding. For the Pro Max and this one, but judging by the RAM base location, this is still based on the old M1. Not sure though. Maybe not. Yeah, that looks pretty similar. It's just the third one is a bit different. But they do have DCSM channels 8. And they both even have the same DRAM config data, so that's looking related. I wonder about if the values are the same. That would be interesting. But yeah, the height values are the same, so probably the same. Let's just wing it and say it's the same as M1. The way that worked on 8103 is that we get the planes DCS stride. There's only one controller. And yeah, global plane-based DCS space. So DCS moved. And that's about it though. DCS moved up. Planes stayed the same. It's possible the stride is different for the planes, but not so sure. Oh no, because the size is the same. It's just the DCS moved up. And I don't know what a fourth offset is, and there's some other random stuff there. Because the T6000 one has a different thing with more. Let's see here. ADT M1 Pro ADT M1 Max ADT, for example. See, this one has one reg for each controller, which there are 8 of them in the M1 Max, and then internally the offsets are hard coded. And look, DCS is at the yeah, that makes sense. So look, DCS global offset. Okay, so this might actually be the T6000 one. It's just that the way it's expressed in the device tree is following the 8103. But DCS moved to the oh no, but global isn't though. No, it is. Wait, hold on. What? I'm confusing myself. No, it didn't. Sorry. DCS, yeah, DCS for some reason moved up. So unless, yeah, it's not the same as Pro Max. So yeah, I don't know why they did that, but whatever. I'm just gonna guess for now that this is the same as T8103 and see what happens. So I think this is currently broken. Shell. Yeah. Keep bringing that. Let's hope that catches it. Yes. That did not work. Oh, because we're back at the. This lovely. Also, my camera moved somehow. Yeah. So yes. Hopefully we get the serial now. Nope. I did that. Why does it do that? Yeah, I need to fix this someday, but like I only use this this USB PD interface like literally for this for bring up on a new machine, so I've been too lazy. Okay, there we go. Let's see if it works this time. That's R. Oh, mini VV, that's wrong. When did that happen? Probably when we change some of the mini version stuff. Oh, right, because that is a tag now. Yeah. Further to RMMMU mapping on map. Okay, that's interesting. That is correct though. Those do look totally valid, except for this one. That one's a dummy. I'm pretty sure. That one's correct though. That looks good. So we have something with the bits are not getting checked properly. If start does not equal end. Oh yeah, it wouldn't equal end because I'm adding 1 anyway. I think there's an enable bit that I'm not that I don't know about. Let me see if I can. We have a shell here. No, now it just died. So we have these are the plain regs. The plain regs are the first thing in the device tree. Which is here. Yep. And we have TZ 680 684 times 10, yeah. Plus. That's wrong. Oh, global. Sorry, plain is the first one. So that's wait, no. Yes. That. That's probably the enabled bit. Oh wait, that one is okay. 6B0. Okay, 6C0. Okay, maybe that is enabled. D0. Okay, that one is disabled. Yeah, so that does look like an enable register. So let's add that just so it's not dumb, but still, it is enabled. So that's not what I thought it was. Yeah, start does not equal end is not a useful test because we actually do check. We had one there, so that's it's never gonna be equal unless it's like negative. Is it just because it's at 0 in the RAM base? But it already has the RAM base though. It already has that bit. So why am I even ORing RAM base into this? Shouldn't need to do that. Unless it was different in T6000? Yeah, I'm not sure if I need to do that. But either way, what happened here was failed to RM MMU mapping at foo. Oh, well, yeah, because that's not even a page size. That's why. It's not even aligned. Okay, the question is this actually TZ? Like, is this actually broken? This should fail. Yes. But that one works. Okay, so that's kind of bullshit. Yeah, I don't understand why that is enabled, but has like dummy values. And then like it still works, even though it's supposedly it's locked, but it isn't. So yeah, I'm not entirely sure what that's supposed to be about. That almost looks like an iBoot bug. Like it enables that, but then it actually isn't enabled. So I guess if enabled and start and let's just do it like this. Yeah. Just let's complain. Uh bad bounds. Okay, let's try that again. I keep doing that wrong. Mini could do USB PD stuff for a simpler hardware UART. You mean like instead of using the macOS thing? Oh, you mean just when starting up? Like locally? Yeah, it could. Yeah, that would work. No, but the problem with what the problem with that is? The problem with that is that those pin mappings get reset depending on PD negotiation anyway, and I'm not even sure if they can be set when PD hasn't been negotiated. So it would make it simpler, but it would still be flaky for other reasons. I think it's a bit questionable. Well, it worked. Oh yeah, look at that. It's alive. It even claims to have initialized USB. I'm kind of expecting that to go very wrong. Unless what darts was that using? Uh Yeah, it is T8110. So I'm expecting USB to be very broken. Is it? Yeah, no, that did not enumerate. Yeah, no, that USB is very broken. Yeah, you can see the that was the recovery mode thing, but then yes, no, that was not going to work. But everything else works, so that's good. Any weird messages we have? AIC2, that's good. Cool. So this just works. It's using the same interrupt controller from M1 Pro and Max, and it worked. It at least it claims to Rick size 08004. Is that right? Let me just double check that. Oh yeah, because I just get event +1. Yeah, sure. Yeah, 1 of 8 dice. So they're still using that instance with up to 8 dice. Obviously, that just means the block can support 8 dice, not that the chip can support 8 dice. Obviously, this doesn't have any multi-die. Watchdog is working. Yes, it fixed up some pmanager stuff. All that worked. Nothing weird there. Frame buffer. Apparently, even the MCA stuff is working. Yes, we don't have the clusters. We should do that. And there's no payloads. So yes, the next thing is Dart, but because I saw that cluster thing, let's do that real quick. That's easy. Actually, no. It's a bit annoying because of the way the pmanager registers work. So let's do that later. It's not critical anyway. So yeah, the next one is going to be writing the new Dart driver. I believe we have a prototype of that in the Python. Yeah, Dart 8110. Which was done as a separate file for reasons. It does share a lot of the code. This needs to be refactored at some point. But I think it's actually, if I remember correctly, this is just using the different PTE register format and different global registers. PTAT, oh yeah, this has T6000 and this one has PT offset. Apparently this is 3710. I'm not sure about that. It has the read protections, uncacheable. Yeah. This is also uncacheable, I believe. Yeah. So basically, actually, what hardware revision is this? I think we haven't checked that because I think R mentioned whether they're using hardware rev 1 or 2. Where is that? Is it just in the ADT? I fixed it. Dart T6000 PT format in Mini yet? We haven't fixed that? Revision is register 8. Oh yeah, version. Okay, that's what it is. Major and minor. So let's look at USB. Dart USB 0. That one is here. That's fine though. We'll just unhandle DP15. Yeah, okay. Obviously that's all from broken USB stuff. That's fine. Shell. Let's get a shell. Yeah. 8. That's 1. That's hardware revision 1, isn't it? Major, minor. Yeah, it's just 8 bits. Yep. So it's 1.1. So in the Dart.c, so this didn't have T6000 yet. I thought we. I guess we. Wait. So how does this work in T6000? Is this because the USB? Did we just bypass them? No, but that never worked though, right? In it's compatible enough for TD103 to work, but what about the PTE format? Wait, how does that work? How did this ever work? I mean, the offset is different, right? Yes, the register interface is the same, but if the PTE format is different, then how did this ever work for the USB? Or is it just because we bypassed those? Uh, no, but we do enable translation of these. So how did we ever get away with... No, we do have the offset T6000. We do have that supported. Offset mask. Yeah, no, we do have that. Oh, was it because it shifted up, but then... Oh, was it that hack where we, like, used extra bits or something? No, we do field get. Yeah, okay, we do handle that. Yes, okay, so it's fine. Yeah, so then it's fine, right? Then we can just then it's supported. Then I just need to add the new register interface to this. It's only the valid thing here, right? The uncached thing that we didn't handle properly, right? So I'm just gonna make a PT flags. We'll use that as a global thing. And I think the uncached thing is true for T6000. That wasn't valid. That was like the subpage protection enable, and it became uncached. Yeah. So let's do that. Because that is done properly in this one. I think. Oh, this is still wrong here. But yes. I'm not sure if that's uncached or like real time. It's like real time or something. Uh, and then we fix up that. And yeah, disable write read, but we don't we don't care about those right now anyways. So so in init, let's take that Dart. Not PT, SP start. Let's set those as the same. So yeah, PTSP and start 0, PT valid, yes. For T6000 and for T8020, PT valid. So let's be, might as well We don't actually need that because we are setting the subpage protection flag anyway, but yeah. That should work. Probably an overused question. What with IMU here? What specifically has to change in an OS implementation to be supported to a new CPU? To be ported to a new CPU, nothing. Well, almost nothing. But the question is not the CPU; it's all the drivers and hardware, right? So the first thing, also the other issue is that Apple does a lot of things in the US that other platforms do in like firmware, like UEFI. So what I just spent the first was it hour or so of the stream, or almost maybe 2 hours, doing was initializing the CPU with a bunch of settings that would definitely not be done by the OS on any other platform. And in fact, they aren't done by the OS with Linux. That's why I'm doing it here in our bootloader. So sort of part of the job of Mini, which is what I'm working on now, is doing all the things that Apple was too lazy to do in their firmware, and they stuck them in macOS, so that Linux doesn't have to. So in fact, once I'm done with this bootloader stuff, Linux will boot with no USB and that other stuff for the same reason as this, because I haven't written the driver yet. So other than the few drivers that need to change because the hardware changed, Linux will just boot without any changes once I'm done with all this bootloader stuff. Like at the very least, we're gonna get a serial console with Linux and the frame buffer, and we'll see if NVMe works. SMC should work. The PMU will not work though, because SPMI changed. The keyboard and touchpad will not work because we know that changed. USB will not work because those darts changed. So that's what I expect will happen with Linux once I get that far. So it's the valid. Where is that set? PT flags, is that used properly already? No. I think that should be fine now. Yeah. So the other issue is those registers that are now all different. So Dart init 80T. These ones are fine. So we need a Dart version or something like that too. Wait, we do call Dart init on that. Yeah, this is kind of backwards now because we set those flags later. Yeah, we need to refactor this. It's kind of backwards. It's a T80-101. I think it's technically the name Apple uses for that one. T8020, sorry. And T80-101, right? Yeah. Oh, T8110, sorry. That's what I wanted. Yeah, might as well do it like that. I think that's also on the proxy, is it? Yeah, it is. Should add .init82 to that, to be honest, but dart.t. Oh, what was it? I keep forgetting. Dart T8020. Let's go up here, make a fast start, and dart.c. Yeah, we weren't doing anything with the real-time flag yet, but mm, all right. So T8110. Don't need the prints anymore. And now these settings have to move into Dart init. And then we set these over here. We should store the type in here somewhere. Enum. And then for these, the init is the same. We do need breaks here. For now. And then we can get rid of these. Unit first. All right, so now what about 8110? What's different here? I probably know some more about that. But the registers are different. Is it mostly different offsets? Are the TCRs the same? No, the flags are different. The bypasses are different. Translate, enable, yeah, those are all different. TTBR is the also different. That's annoying. But sure. No, we don't even have the TTBR setting here. I guess this is only dumping right now. We never set a new TTBR. Oh no, we do. Yeah, okay, it's just the page. So that's the same. It's just shifted differently. Sure. Are these also using substreams like this, or I do have 4 and 4 also, or is it different now? Because you have it as 256, but Yeah, so 256 stream IDs, but what about the fact that there used to be 4 TTBRs per stream? Because there's like 4 bases. Is that still a thing, or is there only one base now? Because before we used to have 4 TTBRs per stream because the address space was that large, right? Anyway, I'll just keep adding bits for now. Oh, there's only one TTBR per stream? Okay. Actually, you know what? Let's do one of these like type structure things. And then for TCR enabled, it would be Dart. State enable, disabled, disable. Sorry, DCR bypass and Dart. And that's the same, but with the PTEs in 6000 mode. PTE, it's just valid in that case. And then for 8110, 6000 here. That's right. And then 810 for that. Do 1 and 2 for that? Nah, whatever. And then we just set type and dart times equal dart 2020 break. Get rid of that. Break. And then we need to do something about the registers there, but we'll see about that. And then we also need TTBR valid. And these are going to be the same. Might as well keep them like that for now. TTBR valid. Oh, sorry, TTBR address. But then I need to extract that. Yeah, more like that. That does not need a parentheses there. TTBR valid. And then that macro needs to change. I'll fix that in a bit. PCR enabled. We do need that. That is now in params. That should be TCR disabled, and then just those are registered addresses. TCR is always consecutive, though, aren't they? I think so, yeah. Yeah. TTBR count. Let's see per SID. define a max for that. And then we can just set the off to 100. 200 for that one. And then these are what you had here. What was I working on before I got the M2? I've been doing some like we had the issue with the that I wasn't doing it on stream though, but we had the issue with the new macOS version breaking the some of the drivers in U-boot and Linux, and I need to get that released. So hopefully I can do that tomorrow or so. But yeah, I've had like more sort of bureaucracy type stuff than streamable stuff going on lately. All right, Dart TCR. So this would be Dart params TCR off. Yeah. Yeah, that should work. Actually, I can just redefine those actually. Is Dart plus Dart params TCR off plus Dart device TBR TTBR off plus 4 times Dart params TTBR count times Dart device plus 4 times index. It's no seed in this case, just do that automatically. Yeah. Dart TCR, why is that not working? Let's find the TCRs and the TTBR. Yep. Yep, that one's fine. It's part of init. And then here, What's the error there? So why am I getting like errors in random places? That doesn't make any sense. Oh, probably because the compiler flags for the includes are wrong. That's why. Yeah, I'll have to figure out if there's a way of doing that for the language server, like making it too few arguments. What? Oh, no, that's fine. What? Uh oh, there's parentheses. That's wrong there. Okay, there we go. Yeah, it might actually work as a build. Kind of. Oh yeah, I still need the TT word count in a bunch of places. Still miss that. That should work. And then yeah, int on u64. Should already be an int on that one. Type S. Yeah, then yeah. There we go. Um, then the TLB invalidate is different. Let's just stick this everywhere and that way all the compile errors will tell me. Where's lock on this one? Dag lock? I'm not sure, but oh, there's a different locking interface for this one. Yeah. Yeah, I'll figure something out for lock darts eventually when you get to DCP, but don't care too much about that. Right now. So T20 error. Do we care about any of that? I don't think so. Yeah, it's just a stream command thing and stream select. So it's just a TLB invalidate. And that one is done. How on the new one? So this one just sets the command with, yeah, it's done a different way. So let's just do it. Let's move these down to after this. And I'll just use a function pointer for this one. That one is where? What is the index about? Oh, for like specifying specific TLB operations. Um, I'm going to call this command. You don't need those for now. 31 is busy here. T to 20 TLB invalidate. Why is that? Zero, it'll be invalidate. And then for this one, we just do not rex TLB tart, not tart. Command. And then we say up flush SID. Zero TLB command stream dart device. There we go. And now we pull command up. Busy. That might work. And finally, let's stick it in here. Oh, actually, let's call us invalidate before that. So. That does get called in init, so I do want it. Might as well just do it like that. Then if this is only used internally. Okay, does that build? No, dot config. That's this one. The config lock. We'll deal with that. Okay, is it going to work? Let's try. Mind you, USB might still be very broken anyway because the okay, it claims to have initialized USB and the darts. That did not work though. Does it actually? It's actually reset. Kind of. Oh yeah, I didn't enable the SID yet. I need to do that, right? I think it's because those were always enabled. Yeah, we don't do that in Mini. We should. Um, so why are there multiple? Oh yeah, because it's just 4. Wait, 32. Yeah, it's 8 of them. Wait, 8? Yeah, 26 total. Yeah, that makes sense. Um, this is kind of we only do it in the init, so might as well just open code that. So I want to do write 32. So I'm assuming that's how it works. Um, 32. So this is 5 bits. Oh, sorry, that's 11.0. And this should really be doing it for these two. So Dart t enable streams device. And actually, you know what? Let's it was 32 SIDs for these, right? Enable streams. Enabled streams. Yeah. So in this case, it would be set 32. And the new one, it would be write 32 because it has separate enable and disable regs. And this was at okay. Is that gonna work? Still not quite, but this might just mean that it needs a reboot though. Because it might have completely wedged the USB device by, starting it up with a broken Dart. So let's do a reboot. See what happens. That is not working. Okay, so my reboot. Oh wait, no, that's because that's calling reset panic counter. That's why. That would not work. Yes, that's why that doesn't work. All right, let's see if that works now. That did not work. We're back on that. And now this is in the wrong baud rate. Okay, I think it works now. Yeah. Okay, still not working. Interesting that it gets a connect done for EP15 though. That's weird. I'm not sure if that means the Dart is broken or something else. Let me get the shell in and just read the Dart error registers. So those are error address low and high 170. Is that where we map it? Yeah, it is. Okay, so it's faulting. Uh, oh, from ADT, that'll work. Okay, that's clearly not working. All the TTBRs are invalid, so something didn't work there. Also, remap is like random. That's not good. That doesn't look right. That does work, so why? Oh, that would do that. Typo. And these. Huh? Oh, X. The T610 mask in T110 is correct. That's still not working. Let me... That's still broken. Remap is 0, though. That improved. TTBR is... That doesn't quite look right. Let me just redo it to see if it actually sets anything. Um, okay, that's not getting set. So why is that not getting set? Mm, probably calculating some offset wrong here. 4 times TTBR count times device. That should be 0. Plus 4 times index. That should be 0. BR address. Yeah, probably some dumb bug here. Let me just add some prints. Um, uh, oh, dev 1. Are we sure that there's only one per device? Because I thought I remember that memory region being larger. And in that case, TTBR1 is getting set. That's still wrong, though. No, that is right. It's just shifted. I'm just gonna try this. Yeah, let me turn it back to 1. Reboot to make sure it's clear, and then we get the proper error. Ah, that again. Oh, it's going into recovery mode. Actually, is device 1 correct, or were we hard coding some stuff? Yeah, because we have reg 1 here. And then there was that silly remap hack or something they were doing. So what about... It is reg 1, yeah. And it still has the remap, so it should be the same. SID-wise. Also, it says SID count 16, which is interesting. Okay, let's try that again now that it's clean, see what error we get. It's obviously still broken. Let's make a script for this. Copy some in. I could use AES as a test, actually. We've been... Yeah, that might be a good idea, actually. Because does AES use the new darts on this one? AES domain hack? Mapper AES. Yeah, it uses one of these. So that might be a good test, actually. I was checking compatibles. Yeah. Dart T path. Why is it an F? That doesn't need to be an F. Okay, that's clearly broken. Those CTBRs did not get set properly. Oh no, I did. Okay. Yeah, I did get mapped supposedly. Still doesn't work though. So I would say there's something wrong with his Dart implementation. This is SID1. Are we really sure that there are only that many TTBRs? Can I get a shell at the end of this? Is it easier? Let's just run a few of those. Mini shell, import, run shell. Base. That's a base. Yes. So we have what I'm going to do is I'm going to set 32 reg space, set all the bits from 1000. Let's do 3000. Yep. And mon, we have a mon, yes. Add, was it? Yes. Add that. Let's get a whole page of that. Yeah, so there are 16 TTBRs. Sorry, 16 TCRs, which makes sense. And oh, okay, so there are, yeah, the same number of TTBRs. So it is a single one per SID, at least for this Dart. Still not working though. Is it the stream enable thing? It claims to be enabled. Dart regs. Where is the error stuff? Flag 1, SID 1. No PMD. Reg. So it's not the SID issue. Enable streams. The TTBR should be fine. Isn't it the 4-level thing? No, but that's disabled though, right? Yeah, 0 remap enable. Oh, it's remapped? Why is it remapped? Is it just because it's remapped? Initialize reg. Wait, why is this not initialized? How did we end up with a remap on that? That doesn't make any sense. No, because I memset this. Yeah, okay. That's fine. Yeah, that's fine then. But the dump here, yeah. XR, where's the error address? Okay, so the error address is 0. Is it because it's truncating? Oh yeah, because we don't have the top bits anymore, right? And was I using some large addresses here? IO map. It's just a random IO map. Is that correct? Like more than 32 bits? That probably doesn't work for AES. That's probably why that is broken. Because I bet AES doesn't have more than the 32 bits for addresses. How's that getting set? Yeah, those are all 32 bits, so that's why. Okay, let's try that again with less crazy addresses. Oh, okay, now it works. Okay, so this actually is working. Um, okay, so that's fine. So another question is the USB one any different? Because I thought I saw more TTBRs at one point, and maybe I'm just making things up. But it's possible that they have different numbers of TTBRs. I don't know. Let's take a look at Dart USB 0. So this isn't useful anymore because it works. So let's go back to what I was initially going to do. The Dart T8110 dump. Let's do all that from the beginning. That's arm IO Dart USB 0. We don't want to initialize, just dump all. And run a shell here. Dump. All right. Yeah, so that is not initialized. Why is it not initialized? TTBR is not valid. Why is it not valid? Let me just chain load. Did I forget to set the valid bit? Okay, yeah, clearly. Why is the valid bit not set? TTBR valid should be bit 0. It's not set. We are setting it there. It is set here. Wait, why? Do I just have the offset wrong on this? 1400 TTBR. One 3721. I'm uh 38 2F8. Yeah. Base 38 2F0000. Oh. Why are we getting the wrong offset? Oh. Right. Because we have 2 darts and we are setting the second one. Oh, maybe we just need to do both. Because I remember we only did one. Yeah, this is that hack with the multiple darts, and how are we defining it in Linux? Yeah, stream 0 on that one, stream 1 on that one. But isn't that... But this one has reg equals to 1, though. Ah, but even then... yeah, so then it means that we need both, because regs... error address low... oh, that's weird. Okay, no, so it isn't hitting this one. So it's hitting the other one. It's just that I have the wrong... I need to look at the second one for our purposes. Let's get the second instance. Whoa, that did not work. Okay, that means it's reading from garbage. Okay, so clearly my... Yeah, okay, that TTBR worked. But... And we're writing something larger, and yet it's not working. So it's like that bit... Do I have the shift wrong? What bits can be set in the TTBRs? The shift for that is TTBR, reg, valid, address, page bits. Page bits is 14. That's enough for everything, yeah? I think I have an offset wrong then. RTTBR shift. Oh, it's 12. Oh, that's why. No, but then isn't really the issue just that... Ah, yeah, so there is something weird in the low bits because D is not... It's not C. If it were C, I would expect that. Okay. That's the problem. That is the problem. TTBR shift. And TTBR shift. So yes. All right, is that going to work? Yes, they are shared. Aha, it works! Yes! All right, that was it. Cool, we have USB. And everything else basically works. Only the... yeah, so if I do mini and reload now, it works over USB. Yep, works great. It's running. All right, so now is the time to flash this again. Because I do not want to deal with serial anymore. So I'm going to go back to macOS and do the kmutil thing again. That wasn't that bad. Once I didn't miss anything. I should probably commit some of this stuff too. Let's do the chickens first. Not that. Yes, that. I'm gonna do the ads separately from the. Wizard. Chickens. Hearthman Ice Storm. And that's just the new ones, right? Yep. Chickens. Chickens. Let's set the config stuff. And do the bring up thing. Oh yeah, I forgot the hit stuff. I need to do that. Not that, not that. But yes, all the bring up things. I need to do that one too, but and then the that one, yeah. Fix that version number thing. And let's fix the chickens. And also the tools has that one register added there. Might as well amend that. And tools. And then yeah. So I'll do everything on the darts. And that also needed the proxy change, so proxy client mini proxy.py. And then what else do we have in here? Yeah, Okay, that should take care of that. And fix the order of these because I need definitely need uh the defines first. Put the bring up stuff first. And the sock ones first. And might as well kind of make this in vaguely the order I developed it in. So, and I do need that because I always forget, and then the bot complains about that. Oh, what is unstaged? Oh, that. Yeah, we don't need that. That we can drop now. We don't need that anymore. And then here, might as well do this. Yeah, I don't want to do that. Uh-huh. And this one... Yeah, and then this... And that too. And finally that MMU off thing. Sure. Yep, that indeed changed some stuff. That's good. Okay, so now, yeah, let's flash that. I keep forgetting the kmuto command line. Oh, and the... Oh, it did remember the Wi-Fi. That's interesting. You know, I only set it in the recovery environment. I was expecting it to not remember that, but I guess it does. Interesting. What macOS version the M2 is running? The same one that was it Jandao mentioned on IRC, which is like the old. If you look at 12.4, the older one in IPSW.me. There we go. It works. Cool. All right. So, next up, I mean, technically I could already run Linux, and I'm pretty sure we get penguins. Do we want to do that? Well, I need to start writing a device tree first. It's going to be very similar to the M1 one, though, I think, since they didn't move everything. But the other thing is I want to fix the PMU thing, which means I need to run macOS in the hypervisor. This is YouTube, so I can do this. I don't know when there's I guess I have to click end poll to make it stop. I guess there's no implicit deadline, so yeah. Let's see. While that runs, I'm still gonna write the a bit of device tree while that runs. But people are saying penguins anyway, so M2. Oh, hey, Dreamer. Yeah, it looks like people are saying penguins. It's not a landslide though, 70%. But yeah, penguins is winning, so I guess penguins it is then. But I am gonna once I get penguins, I'm gonna switch back to the hypervisor because I need to work out that PMU thing, and yeah. All right, so T11Z. Oh, sorry. All right, so TM3 M2 stock names 814D. Do we know the code name for this? I don't think we know the code name for this. We don't know what these relative capacities are. That's gonna take a guess. Blizzard, Firestorm. So yeah, let's get the clock frequencies out of the way. Although CPU Freak isn't gonna work because Mini isn't initializing it, so I need to do that first. Which means I have to get the cluster addresses anyway. But I bet they're the same actually. Let me just try with the shell. Yeah, they should be the same because those are always the same pretty much. So I think I can just guess that. As long as I have the p state counts right, which are probably the same anyway. I bet that's just gonna work. Mini, yeah. Altered states. Oh, interesting. Those are empty. Okay, I need to get a proper ADT that is like has the full data. There we go. That's more like it. So like yeah, these are it. So what frequencies do we have? I was always guessing which one was which, but it was pretty obvious from the numbers anyway. These are obviously the P cores and the E cores would be no. Hold on. So the previous we had 600 to 2 gigahertz plus a bit for the E cores and 3 for the P cores. Oh, this must be the GPU or something. So where's the... No, this one. This is the P cores. Okay, so 5 is the... Yes. 3.5 they go now. Okay. That's cool. So those are the P cores. And the E cores would be... Where... Should be this one. I think. Yeah, that makes sense. So the E cores go up to 2.4 now? That's pretty good. Is the count right? 1, 2, 3, 4, 5, 6, 7. Yeah, I think that's what we had before. No, we had just 6 before. Okay, so that has changed. We'll have to get the latencies too. Okay, so yes. Assuming these are like that. Yeah, and then they go higher, right? So we have 2 more actually now. 2256 and 2424. We'll have to fix the latencies. I have a script for that, but I don't know if it runs on this one. We can try it. That'll be a good test of other stuff anyway. And then the P cluster one. I should really start working on some scripts to just like generate ADT, like device trees based on ADT stuff. I have the P manager one done. Oh, that one's the same. That's interesting. Some of them are the same. And then I don't know if the boosts start at the same spot. Oh, those are the same. So that's good. So they just have... Oh, okay. They skipped one there. And then they went straight to 3324. And then now we have 2 more. And I can kind of tell from the frequencies that the boosts are probably going to be the 3, starting at 3.3, I think. I think those 3 are going to be the boost clocks. Because they have the same voltage. I think. I don't know if there was a flag for that somewhere here. Well, we'll figure it out with... Yeah. So anyway, if we do it like that, then I'm in Mini. Actually, what P state are we in for the 5, 6, 7? What P state are we in for the E cores now? In that case, because we added a couple new ones, and I wonder if it starts at 2 gigahertz, like it used to. P state let's go to the latencies, and then yeah, that should actually work. I just have to change that. So how do I? Does this print the existing P state? I don't think so. But anyway, it was that address, so it should be that plus this, and that tells us we are in P state 7, which is indeed the max. So it does start up where we expect. And now we need to take the. I usually just set them saying the peak the peak course about 2 gigahertz, which means was that what I was saying them at? CPU freak. Setting it to 7, which was 2.2 before, or what was it on 813? This is just kind of arbitrary, but I was saying the 1956, which was 7 before. And I guess we can set it to 6 now, which is about the same. So in that case, these are actually set all the way up to 7. And the P cores, let's make these 6. And now that should give me CPU freak. Yes. And can I just run the latencies tool? I just need to. I should actually, I should just have some kind of data somewhere that tells us this stuff. Yeah, we should just add a hardware CPU freak stuff. I'm a bit lazy to do that now. So, if you dot, we don't have a get sock thing, but ADT does that work? Yes. A103. And then the maxes were 7 and what was it? 7 and 17. Get rid of that comment, and yeah, I think that should work, and that'll prove whether the multi-processing works, or I messed up the init somewhere. So let's try that. Experiment CPU P state latencies. Oh, starting CPUs failed. Oh, that's interesting. So starting secondaries doesn't work. Well, that's fun. Aha, something is broken there. Interesting. Oh, you know what? Hold on. PicoCom. Okay, no, it wasn't that. But you know what it could be? No, but it shouldn't be that, because otherwise you would have gotten the message from the print. Oh, well, is that running before the ADT? Oh, it might. Okay, let me reboot. Okay, we have that. And I'm going to make sure I make a build that still has that sock configured. So I get early debug. And now if I run the p states... No, okay, so it's not that. Because I had a suspicion that it could be something about the RV bar getting locked, but it doesn't look like it. So if I go to shell... So that means that we might have to go through the hypervisor, at least to get more than a single CPU running. But let me take a quick look at this, see if... Oh, wait. I bet it's just this... I bet it's just the pmanager register offset is bad. Because we get pmanager here. And then we get reg 0. ADT, CPU ID. And pmanager plus CPU start offset. I bet CPU start offset is just different. Did we have that in the old ADT somewhere else? Reg. Yeah, that. So this one, 3B, 7, and then we were adding 5.4 to that. There's a 3B0, but that still doesn't cover that. Air handler has some of that. That's pmanager, I think. Yeah. Wait, why are there two of that? Hold on, what is this? Reg and reg. Oh, that's even log handler. This is disp 0. Yeah, that's just one of the stupid things it needs. Dispex. Yeah, okay. AVE. Yeah, this is just stuff hard coding addresses from that. I gotta see. Is there anything in CPUs? No, those are just the internal ones, not the CPU start. Okay. Yeah, so that's just going to enable core here. Yeah, it might just be a different offset for CPU start. So what does the new ADT look like? The new one, the ADT M2 ADT, was it? No, where did I put this? Here. So, okay, so the size changed, which is a bit suspicious. It's larger now. So it might be that we just have another offset there. It was 8C before, and now it's CC. So maybe I just add like 4,000 to that. Let's just try. pmanager. CPU start. CPU start base, and yeah, we were writing to that +4 and +8. Is it 32-bit? Yes. Okay, those are... Okay, that's clearly wrong. What if I do that? What if I write 32... 4 times cluster plus core? Yeah, so just if I write 1 to that. Not quite. What if I read 32? Okay, no, that's not it. Let's just dump the world here. B7, was it CC? Because I might be able to just like guess. Oh, that did a bunch of error. So there's some stuff there that is like locked or something. The P states look normal. Those are, I don't know what those are, but they look like data. So there's nothing until B0, so clearly this offset is wrong. Because I expect to see a 1 where this P core is started up. And then it faulted at B718? Oh wait, is that just junk? Okay, that's just because yeah. Mon dot, what is that? Mon dot reset? No, is there a thing for that? And now it's failing every time. No, we don't have that. Dot. Okay, so if I add the 1800, that's fine. And then can we read 1C? What can we read? So that doesn't work. 1C, nope. 20, nope. 24. 24 works. How far does it go? Let's just add it and see what happens. So we go from 1. 20 doesn't work. 24 works. I think it was CC. Yes. Okay, so now it failed at 7-0. Okay. Um, 7-4 works. Okay, so let's add 7-4. Now it failed at 8-4. 8C works. Oh, and that crashed. Lovely. That very much died. What's 8C 90? Just gonna guess. Oh, that breaks it. So up to 98 it works. I need to start writing these down because I'm going to forget. This failed at 98. So 94 works fine. 9C. It's just unimplemented A0 4 8 C E0 4 8 C C0 4. Okay, so I think it just ends. Oh no, C8 works. Okay. So I should be able to add these mons. Nope. 8-4 is broken. On. Okay, so P32. 8-4 is broken. 8-8. 8C. Okay. Uh, 8-4 and 7-4. Wait, didn't I? 9-4. Wait, what was the crash earlier? I'm confusing myself again. 8-4 faults. Wait, 8C works. Oh, 8C to 9-4 works. Yeah. That was the 9-4 one. And then this one. Not 9-4, 9-8 actually. Yeah. Okay, there we go. So there's timers there and stuff. But what I really want to know is if there's anything that looks like a CPU start region. This it should be pretty obvious. Like bit 1 set on a couple of adjacent registers if it's the same. That one's a little bit suspicious, but I don't think so. Oh. That could be it. Or here. I'm going to write that one down. It's also aligned nicely. Is that just looped? Yeah, it's just duplicated, which is also, yeah, it could be that because it's probably a very small register set. Okay, let's try that. So if I write 1, 2 to 4, some stuff happened. And if I write 2 to 8, oh, did I actually try running the? No, I didn't. I forgot about that. I want to do that. It's going to fail, but that's okay. And then I'm going to try starting the... And then let's try starting core 4. Nope. Huh. Okay, yeah, writing that didn't actually work. Interesting. Oh, is it because maybe Core 1 wasn't actually started by this? Like maybe there was it was kind of special? It could be that. Or it's that one. Oh, that failed. That just broke. Oh, but also I wasn't I didn't chain load before this. And I do need to chain load because I turned on the UART. And now it's going back to macOS. Um to the recovery mode. Um Okay, you know what? I'm going to unplug this, plug in my Mac Mini, and just take a quick look at what that region looks like. So see if that'll tell me what to expect. If I can find a cable. So let's get shell on that. And in this case, the offset, I think pmanager starts in the same place. Yes. And the CPU start offset was 5.4. And yeah, those were stopped, so that's what, yeah. Because that was like a stopped started thing. So you do get, oh, okay, so it's a mask of stopped core. So I am looking for FE in that case. And if I just add one page of stuff here, see what it looks like. Okay, so it really is just that. I'm looking for FE. If it's the same format. Oh, there we go. That's it. That's it. It's 3.4 now. That's the CPU start offset. So I guess we just do another search for sock thing here, because yeah, I think all these like pmanager register layouts are pretty much just hard coded per sock. So in smp.c. So that moved. I do need to include sock.h for this. Do that. I'm not even going to test it from Python. Just go straight to chain load. Oh, uninitialized? Oh, yeah, because I didn't default. Yeah, it doesn't really make sense to default anything. Is the SSD on the M2 slower? I have no idea. I mean, as long as I've benchmarked it. Oh, also, I need to remove that Dart debug stuff. Where's that? TTBR. Where's that? Here. That needs to go away. Dart. All right. And I just variable Oh, yeah, because that was for the print only. Amend that. And the CPU freak stuff. Did that work, by the way? Oh yeah, we don't have serial now. Well, hopefully we don't need it. I think it did, right? Yeah. And yeah, let's see if it works. Peak state latencies. Yes, it works. Cool. Uh, 3.2 gigahertz. Why not more? Didn't we have more? Did I mess up the... I think I messed that up. Okay, let's send the poll, because obviously Penguins won. Why am I getting 15 if I... Oh, because I'm on the Mac Mini. I'm stupid. Sorry. Yeah. Okay, so it didn't work yet. Let's see if it actually does. Okay, chain load now. Now we're on the M2. And yes, it does work. Okay. All right, that means I can commit that now. And that tells us the latency, so we might as well put that data into Linux, into the device tree. Oh wow, the downscaling latencies are like a lot slower than I expected. But anyway, yeah. That's pretty much right. This one is more like 20. 22, 30, 35-ish. 38, 53, or 39, maybe. 39, 53-ish. I mean, these are kind of estimates for the scheduler to know, when it makes sense to switch CPU P states. But yeah, that's like super. Let me just run it again. It's getting consistent numbers. And yeah, going down in frequency is apparently very fast now. That's interesting. Oh, wait. No, this isn't working. It worked the first time, and now we got stuck at a weird frequency. Okay, no, something's strange. Like the first time. Okay, something's weird. The Yeah, the switching isn't working now, but it worked the first time. So that's why going down didn't work. Because it didn't actually do anything. Um, so it's like we go up and then somehow we can't go down. Interesting. Yeah, but then like why? Okay, so hold on. Let's look at the CPU Freak thing, which did have status at 50. Maybe it's just slow? No, that doesn't make a lot of sense. Um, oh, wait. Oh, wait. No, we have, duh. It's more than 16. It's not 4 bits anymore. I don't know how many more bits it is, but it's obviously not 4 bits anymore. Duh. um, Interesting. So that's one reason why the CPU Freak driver that I wrote isn't going to work, because we are missing bits for the P state. I don't know how many bits it actually is. That would be interesting to find out. Yeah, duh. Shell. The command register is here. Let's just mess with the eCores for now. Yeah, so I guess the 6. Can I write anything larger than that? There's a 1 there, so I need to set what bit for that? 125. What's max 64? Let's just set 64. Okay, so it does go to F. It does go to 1F. You go to 3F? Okay, no, so it's one more bit. It does go to, yeah, so it's... Oh, but then it's interesting because the old p-state status register had only 4 bits anyway. So what, did they just extend it? That's an annoying, like, register ABI break. If they just, like... So how did they do that? So that is 0 right now. If I write 64... Yeah, so 1F works. 3F does not work. Not in the low bits. 1F does. And so what about the status bit? That's 3FF now. Okay, so they literally just... Yeah, they just moved it 1 bit up. That's lovely. And annoying. Huh. I did actually use that too. So also it apparently let me go to p-state 31 now, which is kind of weird. Is that just clones of the last p-state? I'm not sure. I put it with WFE mode. Yeah, it does get cropped to, as I thought, yeah, 15. So 15 is the max. Oh, wait. Yeah, curve, sorry. 5 bits. Yeah, so E is the max with WFE mode enabled. Otherwise, F. And even if I set this to 1, 1. Okay, yeah, so that's a lie then. You can go to p-states higher than the actual max, and they're probably just replicas of the max. I mean, I don't think we can overclock this like this, but if I just go to p-state latencies and make it like, like 20, I bet the frequencies are just going to be the same. So in that case, this needs to be 1F. That is the dumbest register ABI break. Well, I haven't submitted this driver yet, so I guess that's good. Yeah, we're gonna need to make this a per sock handler. Yeah, I know. I need to fix that. And these are fine, but yeah, it should be fine like that. Just run that. Yeah, that's more like it. Yeah, okay. So if you go over, it just is 660 then. So it's just yeah, padding. Actually, the lowest p-state when you go too far. And it really didn't like that. Not sure why. Yeah, it really didn't like that. Probably just infinite loop or something. Oh, I didn't chain load. Okay, there we go. Okay, that's more like real numbers. There we go. So back to the device tree here. Um, 20, yeah, these are about the same. And then these, so the worst case is 8.5 or so. Let's say 9. And then we have 19, yep, 21, 22, call it. 24, let's say. 26, 28, 30. 24 is 33-ish. 34-ish. 27, it's got 36. And now it's when it gets larger, right? 41, 44, and then the last three are the same. 62. Wait, no, did I just skip a bunch? 40, 41, 40, 42, sorry, 40, 42, 44, 46, yes. And then the boost ones are 62 across the board. Yeah. Oh, and these levels need to change. Yeah, so this is easy to add one bit here and just make it work for more p states, but uh um but the problem is going to be this register here. Because also, even though it did let me set the bit in the E-cores, I think the E-core okay, so they both changed. Yeah. Yeah, so they added a bit. So I need some compatibles now. So I guess what we're going to do is we're going to default to 4-bit p states because we've never seen anything smaller than that. And if it's as a fallback, if it's an unknown compatible, then we're not going to implement this set target. This get rate function in this way. There was a different previous implementation that I had that didn't use the curve PS register. So we're going to use that. So the way I'm going to, I think I can look at the git log for that. Git log drivers. I did. Yeah, I did. I think I sent that report before the test submission. So remember, how was I doing this before the? I have an Asahi something tag that doesn't have that. Oh, it just reads the actual p state um, field. Yeah. Yeah. So we do need something here. Stock CPU freak, Apple CPU priv. How are these things done? I need to fix the language server. This looks terrible with all the red. Um, oh, that's unused. That's just garbage. Okay. Um, actually, not even fallback. We can just go and do actually let's just do actually we can just say p state current p state mask. Yeah, and then we can actually just have it as a like that. Um, So I guess I need some compatible data for that. RQ chip. Let's just steal that from AIC. Are we doing that with the compatibles? Yeah, like that. And state. Just say state mask. Yeah. So if we have p state bits, um, otherwise, just read the do what I did here. VFS. What is it called? CMD. Hmm. Hello. Did my machine just crash? No, it's just very slow. Am I running out of RAM? Hold on. Just one sec. Let me figure out what's going on here. No, it's not RAM. I think X is just like decided it's gonna hate me or something. Or wait, hold on. Oh, it came back. I mean, okay, yes, I'll buy you slow completion, but why would X? Is it just because like there's so many things that it tries to create like a giant window or something and like spams the GPU? Yeah, I don't know what was up with that. And how do I get that again? It does match node, but we already have that here, right? With match table, how does that work? I know other CPU freaks do this too, so not AMD though. DT performance. Where's the Qualcomm one? Yeah. It's data sock data. Policy driver data. No. That comes from if device get match data, yes, from the pdev. Where's probe? Here's probe. How does Qualcomm do that? They get match data, set that as data, but that's in CPU init. How does it get the pdev from that? I gets driver data, and where's that set? Oh, it just sets it here. Sure. In probe. Yeah. And then it gets driver data from the policy. No, not the policy. We want the actual device. Oh, it's CPU free get driver data. Yeah, that's how that works. Yeah, we don't use that. So I can just use that. Was that OF match? Not OF match. Info. And then I can just say priv info. P-state mask. And then move this up. And then over here, declare info. And have priv here. Yeah. Yeah, that should work. And then I need to get the driver data. Something like that. Okay. We'll see if that works. But yeah. Hopefully that's cool. And back to the device tree. So we added the latency numbers. That's good. I'll have to run some benchmark or something to get these, but also I think I should at least eat something. I have a sandwich here. Because it is getting a bit late. So I'll just do that while staring at actually while staring at the Apple device tree. Or is that in here? Um oh yeah, that problem. Um Specifically, I'm interested. Oh no, actually, you know what I'm going to look at? Let's dump the P manager. Oh, interesting. So that also changed. Well, I'll have to look at that. Yeah, lots of junk here. What is that? Wait, NV run. Oh no, sorry. There. Yeah, I have to do something about that. Anyway, I'm gonna get a little snack. Yeah, beat. Okay, done. Oh, thanks. Thanks, Joey, for the snack money. So yes, I need the P manager dump anyway. So let's see what happened here. Power gate registers. That does not exist. Lovely. Perf regs, PS regs. Are there any other regs? Nope. So maybe that's just unused. I think we never used that for anything anyway. Um, that's used for nothing anyway. Actually, I think we never used that. It's just commented out. Okay, that works. That gets everything. So these structures didn't change. That's good. Really suck if they did. All right. So yes, I need the P manager ADT to DT. Oh, and that gets it from yeah. Yeah, there we go. So there is our new device tree that I need to wait. Oh yeah, 2P managers because there's two of them on these things. So T8112P manager. And then a bunch of these things will need to be changed anyway, but let's just kind of compare things. First, I can just copy and paste the whole thing into 8112. And then look at 8103 and hopefully get the changes that we always make, right? I don't think we need the eCPU, pCPU stuff. Or the CPMs. So we start at SBR. That one's always on. Those are core device. We definitely want AIC always on. And DWI, I think there was a thing there. Yep, those are fine. SPMI, GPI. It's interesting. There's only one of them now. It used to be more. Get the always ons done. Core device, bus, if PSPMS, SOC DPE, core device. Sense stuff, FT. And then IMX. I said that one was critical. You have all the UARTs here. SIO ID May. Yep, it has the parents. DPA 0. Yeah, the order is different there. DPA 1. Memory control is MCC. Yeah, that one definitely needs to be always on. And the LPDDR4 interfaces. Why is this out of order? That doesn't make any sense. I think I should sort these by address, unless that was added later. Hold on, let me just do that real quick. Oh, I do sort it by block and the items. Okay, then I don't know why that's out of order. Maybe it was just a bad merge. Was that 260? Everything else is basically in order. Yeah, I don't know what that was about. Bad merge, maybe. Um. Okay, then DCS. I don't know if this is 4 or PDR5 actually. Oh, interesting. And these are actually the numbers are out of order, but the addresses are. So 021345. Oh, that's Apple. That's an Apple typo. There's no way this is 021345. What? Really? No way. They just typoed that. I mean, it doesn't matter. These are always on anyway, but 021345. What? The power domains are like that. Two one seriously? I mean, maybe it is for some hilarious reason out of order, but that is weird. Like everything else is in order. Yeah, I I have no idea what the heck that was about, but yeah, sure. If Apple says it's like that, we'll leave it like that. Apparently we have an SMX one now. Is there no PCI ref here? There is. I think we're gonna need that. Is that something we added? Might have been. I don't know what CMX is. What depends on CMX? JPEG. Okay, so that's also media stuff. Yeah, so we need to fix that. Hmm. I think CPU 0 does need those min state ones. If I go straight to RMX, there's no sys there. What depends on that? Dispexed. Okay. What about RMX1? Oh, this 0 depends on RMX1. Okay. And then I think we also need that for the other DCP. Oh, and there are other DCSs. These were there afterwards. Yeah. Yeah. CPU 0. That one does need that. And then the mini one. For mini, we have debug, core, A on device. Almost everything is always on here anyway. Novice PMI definitely needs to be on. A on. I don't know, message. Nub GPIO, yeah. ATC0 USB A on. Always on. But that one can turn off. And then nub fabric. Yeah. Nub SRAM also. And debug switch. That was not a thing in this one, but anyway, yeah, it's Aeon, so whatever. And then NVMe had some fun stuff. I don't remember if we ended up changing any of that. Well, that one depends on IMX. On this one, it didn't depend on anything. Didn't we have an APCI EST though? Yes. And that depends on okay. Yes. Yeah. Oh, and that one's called ANS2, and it's called ANS here. Sure. Guess they renamed it. Hope that doesn't mean it's not ANS3 or something. Yeah, I don't know. I'm using the Apple names here, so. Yep. Okay, that looks sensible. Now for the main thing. So we have those things, 112. The timer standard, Blizzard PMU, Avalanche PMU, yep. Which are not going to support it yet, but that's okay. Reference clocks, hopefully they are the same. We'll see about some of those. So the CPU free gets 12. Now, the offsets are the same though. Is I2C in the same place? Let me open up the that. Why is that not there? 3501, 351. Cool. They didn't move anything. Excellent. Did they move SPI? Nope. Nice. $81.12 AIC. Oh no, yeah. 12 AIC, and then this is just called AIC2. Which should do the right thing. AIC is hopefully also in the same place we do these. Oh no, that one DOC. Oh, that one moved. Probably because it's AIC2, and that changed a lot of things. And it also needs that. So we need to copy that from the T6000 stuff. T6001. Yeah, this is all moved now. 6002. And this, where'd that go now? Die 0. Enter controller at 281. Affinities are fine to set, but we need this thing. So we get uh 3B0C 8000, and then the event register is 3B0 C8. And that's just 4. Sorry, like that. C0. P manager, that's from our dump. Where was it? Where did I get that? A. Best names. That has not moved, so that's good. We just call it 12P manager. 6 consequent V. Everything else is the same. T7. Apparently that's the length though now. Well, whatever. Cool. Pin control. The pins probably have moved. That's going to be a bit annoying to figure out. Let's go to the P manager mini first and get that in there. 3D28. Yeah, that has not moved. Cool. That takes care of that. SPMI has definitely changed. So I call that SPMI2, and that's not going to probe. Where was it? 81.3. Pin control. PC1, yeah, the address is the same, but there's no way the pins are the same. 213 pins, apparently. One more. Sure. That's kind of silly, but sure. Are the interrupts the same? Oh, no, those also changed. That's another thing I need to look at. Apparently all the IRQs moved. That's mildly annoying. So I need to get the interrupts. Anything with and AC is questionable. The PMs are fine. I squared C though. Those definitely moved. Okay, these are just consecutive. 762, 763, 764, 765, hopefully. Yeah. Yeah, 5, no. No. Spy 3. Interrupt 751. Serial 0. UART 0, is that what? Yeah. That's 739. And UART2. Probably consecutive though. Yeah, 5. Yeah. 741. Apple doesn't instantiate it, but it should work. Um, Nobis PMI, that's yeah, that's where the PMU is. We don't have the type, but at least let me get the addresses right. And it did change. 3D714,000. We don't know how many registers it has yet, and we don't even have the interrupts defined. So, but we should. I should fix that for 8103 also. That's on the to-do list. Is fixing the PMU driver. And anyway, it's got 2 apparently. I don't know why it's got 2. I'll have to figure that out, but for now I'm just going to dump him here so that we know what that could be. 384. So I'll have to fix that anyway. Though actually, I can probably fix a lot of that now. Scratchpad is at 8,000. We don't know the PMU name for this. Legacy Scratchpad is at F7. And the RTC NVMem we call it F9. And we need the RTC offset and the PM setting. Offset is at F808. Let's just call this F8. 300, yeah. And then PM's RTC offset is at 8 apparently. PM setting at 801. That's correct. Yeah, that's correct. I think these might be the same as the T6000 PMU actually. Or similar. Where is that? T6000X PMU. Where is that? Yeah, PMU 1. What's a PMU 1? It's PMU 0. But that's called Maverick. Oh no, it is different. But oh no, these are also in a different place. Okay. They used yet another PMU. Did they write down the name anywhere this time? Stowe, apparently. I assume the register is correct. E. Is that where the PMU is now? Maybe that's why the no, but also the hardware changed anyway, so yeah, it's Gen 1, so yeah, clearly that changed. But yeah, the address also changed. Thank you for that. Wait, clock offset at F9, but RTC, was it an RTC offset? Oh, that's the alarm offset. Sorry, no, the clock offset is at F9. So this is 100. Yeah. Not the alarm offset, the proper offset. So that is the same as that one, isn't it? Die 0. No, it's the same as the A103 then. Yeah, interesting. All right, the more things. Are the interrupts correct for this? Yes, I just copied them. Pin control nub. That's nub GPIO. Number of pins 24. Did it really just grow by 1 pin? Yeah, it really did. Okay. Yep, the addresses did not change. Very nice. Actually, for AIC, we're recalling that. Oh yeah, it's I only use the 2 in the second half of the compatible, so that's okay. Yeah, GPIO ranges. This one, 24. Thank you. Team Manager Mini we just did. Watchdog. Uh, there we go. WDT and DB 0. That has not moved. The interrupt did move. And now the SMC. We always had them in order. Apple flips them weirdly. Did that move 3 year? No. Well, but that offset is correct. I think so that should work. ASD mailbox. 12 SMC. 40 and FE is the SRAM. I think that's Watchdog interrupt. Is that wrong? Oh yeah. What did I mess up? $379. Okay, SMC. How do we get the SRAM region base? That's what it is. 23 if yep, that has not moved. Size looks right. All this stuff should be the same, hopefully. Pin control SMC, that's the SMC GPIO. A2, yep, has not moved. N pins is now 18. Yeah, why not? AOP, GPIO, interrupts, starting at 301. And now it's 54. That one's gotten quite a few new ones. 82. Yep, has not moved. ANS. Let's see if I can guess how this goes. 77408. Yeah, that looks about right for the mailbox. We do need the interrupts. 7, 8, 9, and 720. And then there's that weird one that we don't use. Oh, that's the actual NVMe one, right? It should be here then. Yeah. And so those are right. 8 start. We do need a start. And also this is called PS Ants now for some reason. Oh yeah, the compatible updates. I know I'm like gonna forget a bunch of these eventually. But I'll just search for 8103 and 8112 start. Start Coast Guard. So Coast Guard was also Coast Guard. Yeah, it should be the old one because oh no, it's sorry, start version 3, yeah. That is 3. And this is 2. So I did go to 3. Okay. So they did update that. 7BC5, yeah, that has not changed though. What's the length though? Did we write it down as that in that's in die 1 on this one for some reason. NVMe. Yeah, we do have it as that. I don't know if that's actually correct, but whatever. So hopefully that also just works. T8112 NVMe NENS2. And for that one, BC5, BC. Oh wait, did that move? No, BCC is there. Start is a BC5, and then we have 774. Yeah, that looks right. 724. Yep. That needs to be ANS2. Did I change that? No. Yeah, that is right. Okay, now the USB. This one. Well, this isn't gonna work anyway without the new Dart driver, but let's see, 38228. Yeah, that has not moved. Oh, that's the same. Just the interrupts. Was it always the first one for these, or the 990, or the last one? Looks like maybe the last one. That was 777 is the first one. Okay. And then the darts. 0 has an interrupt at 1035. Yeah, all the deltas are the same, I think. Like 1 to 5 is +4, +4 gets you, yeah. And those have the same interrupt for both, which is hilarious. 38, yep, and F8, those have not moved. Those are the same. These are 8112. No, 8. Well, in Linux, we do call them. This is gonna be a bit annoying because it is 110. Yeah. Yeah, T8020 is what we called those, but how is that done? Oh wait. Oh wait, the M1 didn't use those anywhere. It, What did a PCIe-C use on these? Oh, no. Okay, so these were all 8020. So the new Dart was only used for the PCIe on the M1 Pro and Max, but not on the original M1. Okay, that's fine then. So then in that case, yeah, 8110 is what we called for that one. Yeah. Not DWC. DWC can be 12. Dart should be 8110. Probably. We probably should have both, actually, just in case. So this would be 8112 DWC3. Let me fix this before I fix the numbers. For the Dart, like that. These are probably all the same. Yeah, they're all 110. And other than 6000? No, it's okay. So basically, I can just replace this wholesale. Oh. All right. So now going back and getting the DRD0, the interrupts for this. 1031, 35. Dart 2 is still 1035. Then the 31, DRD1 would be 1112. And then the Dart for that. Dart USB 1, 529, 1116. Hopefully those are 52F0. Yep, that has not moved. And then the Dart 0 for PCIe. Dart API 06, 180,000. Yep, that has not moved. You're making my life easy, Apple. So yes, but that also means that none of this is going to work until I write that driver. So that's definitely going to be it's probably going to be the last thing I do today, actually, once I get this up, is make the new Dart thing work on Linux. So interrupts, PCIe 0, that has to go in there. PCIe, oh, there's just one. It's just that there's, no, there is this one. Why did we have two Darts? Oh, because, right. For that reason, right? Because they were, it's one per port, and now they just use one for everything. So I'm guessing they use the different SIDs now. Yeah, SID count 3. That's why. That's why. In that case, is that a range? Yeah. I mean, cells 1, yeah. Yeah, so I'm guessing that's how it's supposed to go. And 681.08, yep. 4000, interrupt is correct. 782. Oh, what was the one thing that changed? Did I fix the address for AIC, was it? No, I didn't. There. Okay, PCIe. That's the other thing I need to do. Mini needs to get a PCIe Fuse map table, and I'm gonna have to Ghidra macOS for that. Probably. PCIe pins. Yeah, the pin muxes are gonna be annoying. PCIe 0 Dart. APCIe, yep. That is hopefully all the same. Looks pretty much the same. The ports 680. Yeah, 681. Yeah, that looks the same. So we do need the interrupts for that. 781, 4790. Which ones is it? I'm guessing 90 is the MSIE offset. Oh, this only had 3. Oh, do we have an extra port now? We probably just have an extra port now. Oh yeah, we have an extra port, that's why. That's fine then. That does mean, though, that I need to add some register ranges. Oh, that one's going to be very obvious, though. 84. Yep. MSI address, MSI vector offset 793. Bus range, that does have to be. It says it was E0. It says it was E02, or is it because it starts? I'm not sure. No, that might be right. Yeah, so we need another port for that. 1.8. I've got the GPIOs, interrupt map mask. That's fine. Yep. Yep, that should be fine. So now we need that reset stuff. Were these always there, those tunables? Yeah, that mini initializes those, yeah. PCI bridge 0. Reset A6. $166. Oh, and yeah, we we don't know the rest because we don't we've never seen these any of the other ports used yet. um that's but I think were they always consecutive? 2, 3. Oh no, there was some weirdness, yeah. 166. Yeah, that's um not much I can do about that right now, is there? I don't know if that's gonna work. We'll try it. Okay, getting there. And then SIO. Yeah, has not moved. It's just a new kind. This is the audio stuff anyway. We do need the interrupt for that. NCOs 3B04. Yep, has not moved. No interrupts for that. How many channels does it have? Hopefully 5. Yeah, it looks like 5. And then ADMA. That's on SIO2. Yep. $760. And MCA 0 apparently. 384, 4000. Yep. Interrupt 753. Are these just like, yeah, they're just consecutive, right? 4, 5. How many do we have? P manager will tell us that. Just looking for the P states. Okay, it does go to 5, so I think we can just infer that it goes like that. Yep, 8112, also ADMAC, and NCO. The clocks are probably wrong, but yeah, let's just assume all this is reasonable. And going back to here. Yeah, 4 and 3. Yeah, that makes sense. All right, I got to the end. Make sure we get the 12 P managers. There's a device tree. And now I need one for the actual device. I'm only going to put part of the stuff in there, though. Apple. So let's get the JXX one on 12JXX, and then this will be 293. What was this? 493? Yeah, 493. Ah. All right. 493. Here we go. DTSI. No, DTS. It is right. Why is this not highlighting right? Source. C. C493. T8112. ARM platform. Apple Long 2022. Yes. What is the Broadcom board type for this? Wi-Fi. I did not like that. There we go. Antenna SKU info and what island? What's the local MAC address? That's not a MAC address. It has like extra. Oh, it does have. Yes, Kyushu. Oh, cool. So we're still in Japan. Excellent. So we went from Honshu to Kyushu. Yeah. I approve. This is not going to work. Spy 3, because I don't think is there anything in Spy 3 yet? Touch bar is on Spy 3. and some randomness on those, but definitely not the keyboard and the touchpad. Yeah, Mesa's on SPI 2, and that's it. So yeah, I'm gonna leave SPI 3 in because we're gonna use it. But that's definitely wrong. So we can kill that. We don't need the... There's only one dart now. Okay, so we did delete those nodes. Then I guess I'll leave them in and just say XXX fixed GPIOs or something. Or just take them out. Yeah, we can just delete them. Port 01, port 02... Sorry, here. Port 02. Yeah, I'll just... to do GPIOs unknown, so just comment those out, and it will probably fail to probe if those actually exist, which is fine. And then I squared C. I squared C 0. I hope I don't blow my speakers. We do have all of those disabled. Only using J293. Let's see what Apple says about those I squared Cs. Those comments don't make any sense. First, let's get the USB port I squared C's done. Yeah, so these are in I squared C0, as usual. Let's get that in here. Wait, what am I editing? Oh, 493. Yeah, that's fine. 493, I squared C1. These are the speaker things. So JXXX should be for the general ones. Apple M1, Apple M2, MacBook Air Pro. The Air is not purchasable yet, but one Mac Mini Pro. Yeah. Apple M2 devices using T112, target type D493, and the other one was also D413, right? So hopefully that makes sense. The serials are fine, the chosen is fine, all that's fine, memory is fine. Those are fine. I squared Z0, those are probably the same. HPM0 is... Where's the address? 56 and 63. Is that right? I think that's right. Yeah. The interrupts, though, is a GPIO on these. $107. That is AIC, supposedly. Yeah, HPM0. That's the guy squared C, though. That's fine. But then the bus manager interrupts 8.1. Okay, so that's the GPIO. 114 is just GPIO. Yeah, pin control AP. And so the interrupts are 8 and 1. But we only use 1, though, right? Was it also like that in... HPM0? These had it at 1061, yeah. Yeah, so 8. Oh, maybe it's just the range. Maybe that's why it's 1. It's just the range. And then the registers, well, the addresses are correct, I think. Those connector stuff things should be fine. 321X, yep. The data receives hopefully are mapped the same. And then the Wi-Fi, which I think is the new one on these machines, someone said. So it should be the same as the M1 Pro Max, I think. Which means I can just copy and paste that part from here. We do need the power and GPIO for that. Those were Wi-Fi chipset. Where were those things set? There's a helper thing somewhere. CIE. What do they call that? Reg on, I think. Yeah. OD. Which is 13, so that's correct. No, SMC again is not. Oh, no, SMC is going to work. It's just the PCIe that isn't. So that has not changed. That's good. Yeah, we'll go with that. Yeah, it's like how they have a hibernate device. Like, what does that even mean? You have so much random stuff that doesn't make sense. All right, that's good. That's good. That's good. That's good. Wonder if it compiles. All right, so this has to go in the make file here. So actually, it's built. Oh, and I'm still missing the 12J 493. I still need the XXX one to be complete. No, did I just do that? I just did most of that, didn't I? Yeah. And 493. Yeah, I did do that. The backlight. No, there's stuff here. Sorry. I was looking at this one and then I got distracted. So this needs to delete those ports. Then the escort Cs. Yes. Jenna mentioned please use the thing at the base. Yes, I know that. I was going to do that. Because that's actually not merged yet in the Asahi branch. The submission that moves the Dart code out to its own page table implementation because we weren't getting the changes we needed merged into the ARM one. So yeah. So SRC1 has a speaker. Why is it in 2? That doesn't even make any sense. 31 and 32. I guess they've moved. It is in I2C1 at 30. Oh no, because they called it as Oh, it is reg. It is 31, yeah. So it's the thing at the end. Okay, so it's 38. What's ATCRT? Is that one of those redrivers? Probably. Oh, there's 4 speakers up now, apparently. So right front, right rear. Is that really left front and left rear then? Oh yeah, it does have 2. The other one also had 2. But they've moved. It's now 38 and 39. I hope that's correct. Might not be. And the interrupts for that are 11 apparently on pin control IP. Hopefully, this one doesn't even have like anything. What's up with that? They like only define all that info here. I don't get it, but yeah, apparently they're all on the same GPIO, so whatever. 11. Speaker protection 1. Yeah, we need to figure that out. Speaker 3, speaker 1, and this has yeah, I don't know. I'll define them, but hopefully I don't blow my speakers because I don't have Apple Care on this. And then 18 and 19 for these. On 3, no, sorry. On 3 it is 3B and 3C. And this is SN012. Was that the right ID for that? I think it's the same as this one, right? No, this is a TAS. Is that new? Oh, that's the M1 Max one. So how were those done in here? Yeah. So they are the different ones. And those are 3.8 and 3.9, yeah. So that makes sense. Yes. 3.8, 3.8, 3.9, 3D, VC, yes. They're on the same interrupt. Left rear, front, right rear, right front. Hopefully those are the right numbers. 3B, 3C, yes. And then the jack was also the same as these, I think. And we don't have that yet. So, yeah, that's disabled because we don't have a driver for that. And then the backlight we don't know about, which is... I can find out real quick if SMC works. It does. Cool. So which one did we have before? We had it on 18, which is 1, 2. Yep. That's it. Okay. The screen just, since you can't see it. That is, oh. Sorry. So yes, the backlight is backlighting. This is the hack backlight anyway, the on-off thing we have right now, but it's good that it's, at least we can keep that. This would be J493, Mac Audio, integrated audio. Yeah, and we're going to leave this disabled for now. And there is no headphone jack support yet. Yeah, okay. That, I think that's it. All right, 112, 112, 112. Did I get the make file right? Yes, J493. We'll do the error later when I can actually test it. All right, let's see if this compiles. Make sh-j8. Nice it at least. Our computer is going to slow down. Nope, syntax error. 8112 DTSI 843. We got pretty far. That comma. Oh, and this should be 8112 PCIe. Yeah, Are there any 81 things left? Yes, ping control. That has to change. That's it. Okay, that was good. Syntax error 859. Yeah, same thing. That comma there. $10.87. What? Oh, the P manager. Another comma. No, that's fine. Unable to syntax error 10.87. Oh, that that needs to be an underscore. Oh yeah, there's no CIOV. Those are the weird voltage things. But yeah, I'm guessing, is that how I did it last time? Yeah. P handle references. CIOV. Yeah. Yeah, that's just oh, that doesn't even have anything on this one. Oh yeah, I think I just removed those. Yeah, okay. Let's just take the speaker limiting code. I have to ask Povik about that. So while that builds, let me look at that branch and pull that in and merge it in or something. Yep. Yep. So this was log bits T6000 Dart. I'll just replace that wholesale. And do we have the suspend resume in this one? Yes. Cool. Let's just replace it then. Not while it's compiling though. It's gonna be Let me kill that and shouldn't be changes to actually let's just git stash. And then let's make sure I have the base stuff right. Yes, it's called base. Cool. That is either it was already there or nothing changed. Let's redo the merge. And then we can stash apply. Yep, that didn't break anything. And build again. And then I guess while that's building, oh, it didn't build my. Oh, is it because it didn't change? You know, that is there, so. Oh, it's because it was changed and this one didn't because of the git. So while that's building, let's start looking at the Dart code. Yeah, so this goes to IO page table Dart, and that's going to use the same stuff. It's just the registers are different. So I might as well start working on this while that runs. That's a long file for what it's doing. And then we're going to need a bunch of stuff for the registers. So I guess I'll do this the same way Mini did. Pretty much just copy and paste stuff from there. Probably need sit count too. Well, that's the max. Should we be reading those from the should really be max sit count. I don't need a PT flask because that's done already. Yeah, I'll have to change those defines. Max sit count. Yeah, let's just go like that. Don't need offset mask. Okay, that failed on Dart probably because I'm touching it now. Yeah, well, we know that. Let's comment those out so it builds. It should build a bit. Oh, I need the defines for that. Hold on. Reload. That's fine. Apple Dart. Oh, I also need the max TTBR thing. Oh, it is there. TTBR count. That max streams to 56. Max darts per device. Is that a? Oh, it's because of the stream map. Nonsense. Yeah, that should be, it needs to be calculated. Because that's gonna be, it needs stream enabled too now. Dart stream all sitmap. Yeah, that's gonna have to be a bit field now because it goes to 256, which is a bit annoying. Um, all right, let me just hit compile. Um, without touching that. How does that work? Push. Yeah. Get some penguins and then continue on the Dart. Oh. Okay, yeah, it really broke CPU Freak apparently. Because it's that. And I called that max P state. Because it's info now. Now if class priv info. Yeah. Yeah, that's just missing an open brace there. Almost. Oh, comma. Comma, comma, comma. Compile time assert. Field get does not work with variables on Linux. Lovely. Is that a thing? Is there any like non-compile time field get? Oh, that's annoying. Okay, now it builds. Is it gonna run? Are we gonna get penguins? Chain load. Dual Linux PY. Oh wow, I've always been running on the hypervisor, and I'm gonna do an actual raw load now. Oh, sorry, no, wrong. Yeah. It's built. Many proxy clients. Um. No init ramifest for now. Debug. Yeah, that's fine. That should give me output through serial, which I still have running, and I have the PTS open, so we should see it. Verbose debugging. Keep forgetting what the arguments are. Early con. Let's see what happens. Hey! First try! How's that? And NVMe failed to attach the power domains. Okay, so some things are broken. But we got penguins. Even got 8 penguins. I'm going to tweet that. Just 1 sec. I'm actually going to hold on. I'm going to slightly edit that because it's a bit hard to see. Hold on, let me just do a thing. Just 1 sec. I'm just picking things up. Oh, it still says 13-inch M1 because I messed up the DT. Okay, let me fix that because tweeting M2 M1 when it's M2 would be the dumbest thing. Yeah, I'm dumb. Yes. Let me just reboot. That still counts as first try. It's just the text is wrong. Just one sec. You fix this up. Actually, I might as well just show you what I'm doing. Doesn't matter right now. Now it says I'm 2. uh, oh wait, where is unsharp mask? Where did unsharp mask go? Sharpen. They renamed it. Yeah, it helps. Yeah, that. Make it a little cut in window so that. Where is that? All right, something like that. Into Linux 2. All right, just going to tweet it. Yeah, okay, that worked. Just give me 1 second. Okay, so now back to, let's see what broke. Also, it rebooted, and I'm not sure why. So let's see what we have. The CPUs are fine. Interesting. DPA 1 is not on. This CPU 0 is not on? What? Oh, I guess DCP is... I guess DCP is in is in standby mode then? That's interesting. Sure. Okay, let's turn that off. Because, you know, as long as min state 4, we'll buy that. DPA 1. Why is that always on? That doesn't make sense. Okay, so I failed on and then message. Hey, that wasn't supposed to be always on. Okay. Wait, J493 headphones. Oh, that's because I probably forgot some binding stuff. Oh, it's probably, yeah, that's probably hard-coded in the driver. I'm guessing. So SMC did probe. That's good. PCI we know was gonna break. Well, first of all, it's missing all the tunables, so that's expected. And then simple DRM. So what failed? NVMe exist. GenPD? How did we end up with a duplicate GenPD? I think that's a bug in the NVMe driver, like trying to, when it fails probing, it tries again or something. Oh no, it's because no, it shouldn't be that. Anyway, I think it's is it because it was it trying to like root wait or something? Probably, and then it probably just rebooted because it couldn't find root file system. So let's get an init ramfs in here. Init ramfs. No firmware this time around. I can just use that. Let's just get init bin sh. See if that works. Oh, I need to chain load though. Don't need that anymore. Make that sh. Yeah, NVMe is weird there. Oh, I need to set the console. That's part of the problem. Let's reboot. That did not work. Now it did. And now it's back into the fallback mode. Yeah, I need to fix that PMU thing. That's gonna be the next. That might be the next one before Dart. We'll see. Um. Reboot. Yes. Okay. So where was I? I wonder what that NVMe stuff is, but for now, let's get the how's that console? Um, wow, I don't even remember what the right command line was. Sac. Should be in there. Yeah, I'm not getting anywhere, am I? Yes, that. That's more like it. Still no console. I don't know what it's doing. It's almost like it's waiting for something. But what? Back when it rebooted, what happened? The previous time. Or is that just a watchdog? Maybe I crashed SMC? That would do it. Oh, using, and then it died. Interesting. No, that was still... Oh, actually, you know what? I think it's totally dead. I think it's a... I think it tried to do something that crashed the machine. It's possible it's PCIe. It's possible it's trying to probe PCIe, and because it's not initialized properly, it just totally breaks. Speaking of... Oh, interesting. So, yeah, that one's good. No, Civ didn't work. So what about the PCIe stuff? Did that just, like, not initialize at all? Uh... Unsupported compatible, yeah. Thought so. So yeah, it's entirely possible that the PCIe is breaking everything else. So let's just disable that wholesale for now, just to see if I can get a shell. Yeah. Let's just set that as disabled for now. And try it again. But anyway, it's basically hypervisor time now, right? Because that would also help me figure out what happened. No, it just dies. It really just dies, and I don't know why. Probably something silly with trying to access some memory that it really shouldn't. Okay, so let's see if the hypervisor works then. Which is basically this command line. I don't need PCI enabled devices. I do need to run guest. So yeah, let's just run that loop. See if the hypervisor works. How am I getting access to the mini device without sudo? I just set the permissions with udev. Interesting. Did it just die there? Okay. Also, the screen is... Did it... What? Oh, did I forget the chain load? Oh, yeah, the reset panic counter thing is broken. Yeah. I need to, like, not do that. Let's just disable that for now. And, yeah. I was going to do something I forgot. Anyway, let's just try it. Oh, chain loading. Did I chain load? No, I am chain loading, yes. And then I need that console, which is this one. Oh, yes. The virtualization for the CPU start is wrong. But it did get to Linux. Oh, cool. It's a data board. Yep, it's hitting an address that is probably unmapped. What is that? Hypervisor works. So there's that. P manager. Wait, is P manager in the wrong place? Did I just mess that up? Or did it like cut itself off from P manager? Did it I bet that's what happened. I bet it like killed itself with, yeah, that's probably why it's why the screen is off and everything. It probably did something horrible. Okay. And also reboot doesn't work. Okay, let's just trace everything. Yeah, whatever that is. 458. IMX. Okay, IMX apparently needs to stay on. No, sorry, that was a dependency on IMX. APCIe? No, where was I? MSR. 458. Where am I? 458 is ATC 0? Oh, yeah, that's the USB problem. No, 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 no. That one's fine because it's getting caught. Wait, I'm confused. Why is this data abort thing? Is it something else it did? Oh, is it just because the tracing doesn't trace P? Yeah, I think it's. Hold on. I think a trace all isn't actually trace all. Yeah. And we're back at macOS. We don't want ASC though, but yes, P manager, please. Um. Need to fix that CPU start emulation thing, but all right. 360 apparently is what broke it, and that is CMX. Interesting. Apparently the JPEG is connected to there, and also Power Manager itself or something. Um, yeah, that was an unknown one. So I like the idea that you can power that thing down and then it kills your power registers and you can't touch anything else. Need to fix the CPU start. Ah, there we go. Okay, now we have a shell. So that was the problem with that. Um, also, the screen turned off though, which is unexpected. Oh no, it never turned on, or something else happened with hypervisor. Maybe it's just black. No, it's on. It's just black. Um, Interesting. I wonder what happened there. I don't get that NVMe thing. I think that's just a bug in the NVMe device that is like not freeing things properly when. Yeah, I think that's just an issue with initialization. Does reboot work? Yes. So yeah, what's going on with NVMe? No, that should work. It's the first thing it does. So, oh no, it's probably because yeah, we don't detach when we yeah, that's the problem. Yeah, remove calls it, but that's the error path here doesn't do it, and it's probably just doing a probe defer. Oh, can that just be yeah, PD link is yeah, that can be called unconditionally. The domain detach can be called unconditionally, and those are devm, so those are okay. Yeah, we can just do it unconditionally. No need to actually just do that. That should fix it. I don't know why the screen gets cleared. Like even Mini itself, I'm not sure what's up with that. So is NVMe just retrying forever because it depends on something? But what? NVMe shouldn't depend on anything we don't have. Um, is it SART? SART's in there. Oh, are we missing a SART driver? Oh, is it because SART had the like single compatible or something? This is drivers sock Apple SART is in here. I think it's just a compatible problem with this. Yeah, that's why. Okay, so we have to call this C6000 SART, and SART 3 was BS. Um, that's the problem. So we can just do it like that. Okay, that does work. It like messes up when it does a DC. Oh, that. Oh, it's something about that. It's the. Oh, okay. It's trying to. Why is it trying to? Okay, that's a bug. It's trying to talk to DCP, which we know is like powered down and stuff, and it's messing up the darts and screwing up the display. That's the thing where I turn DCP on, but I shouldn't do it if we've never touched it. I should only do it if it's not external screen. All right. That's booted. Still no. Okay. Start has a driver now at least and a consumer. Oh, the NVMe works. Did I miss the partition list? Or did it just not print it for some reason? Oh, yeah, no, it did. It did. NVMe works. Okay, yeah, NVMe works. Yeah, there you go. That's wrong. I guess this doesn't have GPT support. But yes. Yeah, this BusyBox has like nothing. But yes, NVMe works. So that's one thing ticked off. Let me commit that, now that I know what happened. So yeah, I need to make that hypervisor thing not screw up the display, which means here when I do display start DCP, display shutdown. Yeah, this should only do that if it's not external. I'll just make that public. Do I need bool from somewhere? Yeah, I need. Is that included in types? Yeah. Yeah, it needs that, and then if display is external. Interesting that DCP is quiesced, at least shut down on these machines now. I guess it saves power and makes sense because I think DCP needs to be running on the Pro Max due to the like fancy LCD, but I guess not on these with the more plain LCDs. Okay, let's reboot that. Hopefully that fixes my display being broken. Let me fix committing things here. Yeah, that works. Let me fix the CPU freak stuff. Wait, did I write down the shutdown GPIO? Oh, Povik just noticed that I am dumb. Yes, that's interrupt. Which is the shutdown GPIO? And also the ping controls are still wrong. The I2C stuff. So I need to do that. External power provider, I assume. MCA. Oh, it's just MCA. For which there's no function. No, there is. Oh, that one. 58. Sorry. $88. Yes. Thanks. Hopefully it didn't blow my speakers. Yep. So yeah, the pin controllers are also still wrong, so I need to fix that. I forgot about that. Pin control. Yeah, so I2C1 has 0, 6F and 6E. That one has 70 and 71. $56, 57. $87 and $86. $36 and $35. $83, $82. And then those, I think we didn't know. I think I had to work those out. It has CS0, though. And I think I had to guess what the others were. And then those were the clock rigs, right? Yeah. Maz wants a dump of the ID registers. Let me just do that real quick. find there. Actually, let's just make a script for this. Not there, but I just want to use the sysregs. And there's this reg forward, yeah. I guess that's the A64 because the others are 32, so. Is that alive? No, it's not. Okay, so back to that. Yeah, so we're missing some of the clock rigs and stuff for PCIe. I can probably turn on PCIe, but it's not going to work without the mini stuff. Which is a bit annoying to start doing now, like putting a Git out just to find that dumb table. I could run Mac OS under the hypervisor, and actually, let me fix the CPU start thing first because that's dumb. Yeah, so that one. Uh, let's do it like that. What was anyone 3.4? Yeah. Okay, so now now it shouldn't mess up the screen, and we should actually get 8 penguins with a hypervisor. What just happened? Oh, I can't type. In and also let me do a quick tweet thing. Might as well live tweet the progress. Okay. Where am I? Yes. And that. Oh, that again. It's not you, it's self you. Uh, oh, I think it just yeah, that's the usual problem. Um, and we're back in the recovery mode. I really need to fix that PMU issue. Actually, I need to get an SMC dump and see if they are finally doing something about those. Though I doubt it, to be honest. Um, but yeah, if they're finally doing something about those things and adding SMC keys to access them. But I'm not so sure. Let me do a quick test. Um, um, so for example, the clock stuff. That's the raw one. BT UD wake. Those don't look like offsets. Apparently it's syslogging stuff. Um, yeah, it doesn't look like it. I mean, there could be something secret hidden somewhere, but like how there's like a random syslog that happens there. But anyway, we should actually have me run Linux again. We should actually have like battery stats and stuff like that. Yeah. Yeah. Battery works fine. And probably the power button thing works fine. Yep, that works fine. Well, that's a syslog, but devices. Well, input event 1. Yeah, that works fine. And the lid. Oh, the lid does not. Also, yeah, that problem with no power lid events. Why no lid events? Why you no lid events? Interesting. Power works though. Just reboot that. And interesting. So why no lid events? Does that need to be enabled separately? I forgot how the button things were called. I wonder if something I do in GPIO breaks the interrupt. No, but that power button works though, which is I'm not sure. Okay, the lid events work in here. So the fact that they don't in Linux means that Linux is breaking them somehow. Well, I think I know what's going on. I think it's because I added interrupt support to the SMC stuff for that test. Maybe. Where is this? GPIO SMC. I bet the problem is that this resets the GPIO interrupt config. That kills the lid. Even though we're not supposed to be using the GPIO. I can just trace this in the hypervisor. And it'll tell me what the problem is. But yeah, I think it's just that I'm resetting the Also, apparently the frame buffer is now not working, even though it sticks in Asahi, like it sticks to the logo, so it's not breaking it, but Like Linux isn't seeing it or something. I'm not sure what's up with that. It claims to have initialized, but then I wonder if the frame buffer moved or something. What's that? Oh yeah. Whatever. Um. So yeah, I think GP01 is always the lid. Oh no, but this time it didn't even trace anything. Uh, I need to set power, and no, that's not working. Obviously, something didn't quite work here. Oh, failed to wake up SMC. Is that just a timeout issue? Oh, it's because I ran the thing before, I think. Yeah. Oh, it's because I was running that. I'm dumb. Yeah. Okay, there we go. Yeah. Oh yeah, yeah. Okay, so this works now. In the hypervisor. So yes, GPIO. Some of them get read. And what this is doing is 6. Yeah, IRQ mode. It's setting the IRQ mode. It just reads it though. Oh, that's command action. Wait, no, it's not. Oh yeah, it is writing some stuff. So what happened here? DPO1. Writes 4s. My main command actions is nothing. I'm confused. Where's this coming from? Oh, is it because I'm using atomics here? And that's broken or something? I don't think I need atomics here anymore. Oh yeah, this is I'm like explicitly disabling interrupts. I'm dumb. Also this is just bit inverted. That's why I'm confused. It's just little Indian. RQ enable. Yeah, okay. I'm like deliberately clearing interrupts. I shouldn't be doing that. That's a good thing that I didn't push the new kernels yet, because I think this is a regression that's in Asahi Dev right now. Okay, let's reboot that. That should fix the lit events. Yes, lit events are back. Okay, that's fixed. Let's fix that one. And let's commit what we have so far. Oh. No. There's a format here. By what? Or okay, that's that. No, there are no more. There's no more atomic calls. It's only used for the IRQ stuff, and it shouldn't have been atomic. Because it stopped needing to be atomic when I switched to these sync lock stuff. So that's cool. So yeah, the Dart. Just 1 second. All right. So that Dart thing. I stashed it. Git stash apply. Yes. And let's get to the Dart. So, uh, yeah, this is mostly going to be, translating from A to B and fixing this stuff. Okay, so that's all the defines that I have so far. I'm going to steal some code from the ASC driver. Does that round up? Yes. Should be safe to just write all Fs anyway, so. Dart. What is this called? Dart. Hardware. I guess I might as well look into that locking thing. Uh, so yeah, let's get that one. So for example, this one has yeah, all locked. We really only care about TTBR, I think. And then protect lock. Yeah. I think we can probably just assume that if it's locked, we're not going to try to like unlock it if it's not unprotected if it's protected but not locked. So 210 protect is 200. So TCR base, CTBR base, I guess. This is CTBR and TCR. And lock bit. So lock, just lock bit. Call these without off, and put the offset at the top. Yep. Why are these like not just a bool? Who does that? Apparently Sven does that. I guess it would be 2020. Oh, also that. Also, I'm guessing OAS should be 36 on here. Maybe. I mean, I'm not sure actually. Does this even matter? I think it shouldn't actually matter. Because this is used also in 6000, so it should work with 42. Yeah, it probably doesn't matter. Um, is that the same? Yeah, it is actually. So that's the same. Arms 2 bypass support. Yes. Okay, so those are the same. Those didn't change. That's good. I don't know if the old ones have this one, but does this one mention any of those? No. I'll put it in here for now. We can revisit. Oh, we have the PA width here. That's nice. I need to see if this actually works on Dart 1. Yeah, let me just look at that real quick. I think I need to reboot that. Yep. Is that sane? That doesn't quite look right, version-wise. No, that does not look right. Yeah, no. Unfortunately, those registers do not behave the same. Yeah, there's like extra stuff, and then these are completely different. So yes, unfortunately, they are not compatible. What was that called? Num streams. Yeah, so 32 VA PA width is 24. Which is that 36. Yeah, that is correct. So in fact, we can dynamically set that. So times 4 VA. Oh, this should be times 2 actually. And those are 4. No, those are 3 and 4. Find some SIDs. Get that from the params. Okay, that takes care of that. Um, yeah, then you need an actual bitmap here. I think ASC had some stuff like that too. I can just copy and paste. What was that? No. Did the GPIO one have some test bit and stuff? Bitmap, alloc, bitmap. There's a way of doing a static bitmap, right? Declare a bitmap, yeah. Ooh, and that really need to be atomic? I guess, but that's gonna really suck. Apparently test bit and stuff is supposed to be atomic on bitmaps. Apparently set bit and stuff are atomic. Okay. That. What do I want to do? I want atomic long T in this case. Um. How does bitmap do it? Bits to longs. No, that's not a thing. Yeah, I guess it'll just have to be like that. And then I need to look at all the accesses. All right, sitmap, reach sitbit bitmap dart max streams. Yes, that's fine. I want to get the dart out of that. I guess we're not bypassing in that case. So TCR disabled. So disabled, bypass. Num streams, sorry. Okay, that should take care of the stream counts. Streams. Up there. Okay, so this one is just really like open coded with the with the two options because that's the one useful thing. It's the one like weird case. Dart. Sorry, T8020. Sorry. Although this one would be Dart. Stream. Was it num streams? Yeah. Let's get the Dart variable on there. Num streams. I'm not sure if that works. I don't know if that gets declared inside or not. Let's see how badly I've broken it so far. Yeah, everything is very broken. Yeah, we don't need that one. Set bit. It's not a percent anymore. That's a lot of errors. I think I changed all of those. Seed undeclared, yeah. So that actually needs to be declared separately. Seed. So that will work then. Still very broken. Yeah, no 1% there. And this actually can be num streams. 381. Yep. This isn't even M2 specific. This is already in the M1 Pro Max. We need this for Thunderbolt in the M1 Pro Max. We just hadn't done it yet. So what I'm doing right now is useful both for a bunch of things on the M1 Pro Max, the Thunderbolt and some of the media controllers and some other stuff. And also the M2. So it's actually all useful. 20 increment timeout. Yes, sitmap, stream all. Is that really what we want there? Read stream map. Darts. This is a non-atomic, i.e. Is that a thing? Read long. Atomic read. I think that actually works with any type. Not sure. Yeah, because it's doing it like that, so that makes sense. So if I look at longs, bits to longs. Okay, what else is broken? Yeah, I need to set bitmap set or something. Yeah, that. Uh, I undeclared. This is one. Oh yeah, the Dart error stuff. How are we gonna do that? How different is it? Yeah, we would like to know about these. I assume the SID is somewhere in there. Just one sec. I'll be right back, and I guess I have to do some tests with the AES engine here. Okay. We need. Just one sec. We need a test here. So you have an AS Dart test thing too, but I'll just copy that. Actually, yeah, this might work. This will be good for experimenting. Don't care about the reset for now. Oh, why is DCP there? There was a bunch of random stuff there. So in this case, what I'm working now, the Dart Linux driver. We're not gonna mess with depth. But we are gonna use the reg monitor and with the Dart base. Do we have show error in this thing yet? No, we don't. No polling apparently. We did get the booth thing there. Can I reset that Dart? That did not work. And we're back in macOS. Did I get a dump here at least? Nope. Getting there. If I can get this error register, I mean, I don't need this strictly speaking. As long as I don't mess it up, it won't actually cause an error. But it's very useful for this to work. So, what actually failed there? Yeah, just exception sync, and I don't know. That's sick. I don't need that. This is the one I want. Yeah, I'm not sure what exception happened there. But probably. Oh, yeah, because this isn't even because that was from the M1 Pro, and that's the wrong base. The base I need is that. That did go wrong. Okay, resetting SIO really didn't go well. I guess that one's not gonna work. Oh yeah, because like the UART is there, of course. That's gonna go very badly. Okay. Yeah, at least that seems to work. So can I can make it fail by yeah, so then we get the error. Uh, so the yeah, that just clears the error flag, which is what I expect. And now the interesting thing is there going to be a is there going to be an IRQ flag somewhere? There should be. So first I need to test the interrupt for this. It's gonna be a little bit annoying. I have to get the ASC stuff now. I should really write an ASC driver. There's so many drivers we just don't have because like it's it's been doing lazy stuff like this. Client experiments AIC2 test. Yeah, these registers and stuff, right? So I really just want hardware state. And then I need the interrupt. Which is... start SIO interrupts 0. Oh, okay, so the interrupt is firing already. That's cool. Is there an enable register that we might care about there? $160, $178. 104 is supposed to be interrupt enable, but it's not. It might be interrupt disable though. Might be interrupt mask. So let's try that. Yes. Oh, actually, that's just oh, maybe it's just error enable. Ah, okay, yeah, then it's probably like for different errors. It's probably more like an error enable or error disable actually. Because in this case we have a no PMD error, which is a 4. So if I set it to 4, yeah, it doesn't fire. If I set it to that 04, then it fires. Yeah. So it's more like error disable. And you don't even get the flag in that case. Though probably you do get the actual error. Oh no, but that just clears. The flag just gets cleared. So oh, but that one gets cleared too. So if I just do that bit, oh, then it stays on. Okay, so the error flag is there. Okay, you have to do both. Then you have to do both the actual thing, and then if I disable all of them, but then it doesn't even fire. So maybe in that case, it just the error is just swallowed. It doesn't go anywhere. Okay, so that's that should just get cleared. And I guess the interrupts are already enabled then, because there's no like explicit interrupt enable. Maybe it's in config, but looks like it's yep. No idea. But yeah, okay, that works. So we don't have to worry about that. So it's really just the error register. That's easy then. So hopefully the errors are not disabled. We probably don't actually have to initialize that. Apple Dart. Anyway, what about the stream? We need to know the stream. In this case, the stream for AES is... if it's 0, I'm going to be sad. No, it's 1. Okay, so that's important. Um, The problem is that I can't reset these registers. Apple Dart. Can I? Yeah, it's being a bit annoying. Wait, there is a SID there. Uh. Oh, okay. No, no, but wait, that doesn't have enough bits. Oh, okay, but it does. Yes. Yeah, okay, so the SID is just there then, and that hopefully is actually right. 20. Yep. Cool. Okay. Then all done. So how does that compare to the old Dart error? Can we share anything, or is it gonna be separate code? Dart. Okay, it's a bit different. It's similar, but not quite. So we'll probably have to have a separate handler for that. Apple Dart.c. In this case, the error register is at 100. Sort them by address. So stream is 20 to 27. There's no code in this case. Flag is 31. So how does the handler do this? It clears. Yeah, so you probably want to have that as a register, and then IRQ. Yes. Probably want to just have that. So make a separate RQ handler for them since it's going to be different enough. No code in this case. Oh, I hate it when I do that. Yeah, that should work. And then we just need the this stuff. Clear any pending errors. Should really do that TLB invalidate thing that way too. T8020. Okay. How far are we from compiling? Still very far. PT. Sorry, that was a wrong. No PT PMD. That's not static. Hmm? Yeah. Right, error. Invalidate TLB. Oh, didn't I set that? Oh, did I put it here? I haven't set the prototype yet. Ah, right. That needs to. Yeah. I guess that needs a forward declaration. um, Invalid storage class. Oh, yeah. Ah, much better. I guess that has to be Atomic 64 read. Atomic. All right, this is the set stuff. Stream map, sitmap J, sitmap J. The first one needs to be not a pointer. And there's a J not declared somewhere in 628. Slowly getting there. Um, Start domain. Oh, those are atomic. Okay. Atomic 64 read. Atomic long T. That needs to be an and. Yeah. Um. Yeah. Set bit. Yeah. That one's just not declared. Pointer for an integer. Yeah. 54 set. The new value is. Wait, why is that? Oh, okay. It's the other way around. So that shouldn't be ampersand then. Why is that? Why did I write that? Those are also backwards. Error code. It's not error code anymore. It's just how is it? Is it here? Oh, okay, yeah. So I guess we can call that error code. Just all the bits that are actually errors. Maybe 14 or so. Then the offset stuff. These are not called off anymore. Max streams. It's not max streams. Num streams is just max sitcom. And then params 3. Those are special. And then lock bit. I think I just missed a comma there. Yeah. Almost there. Almost there. TCR. Yeah, it's not off. Whew. Oh, a bit more. Hmm? Oh. The mainstream habits uninitialized. What happened there? 484. Yeah. That's wrong. Just do that actually. Dart undeclared. Hardware. No, it's not hardware. Or oh yeah. Okay, is it going to work? Let's just run it bare metal. See what happens. It doesn't work. Okay, that failed very badly. Yeah, it failed very badly with an S error. Hard to reset. I bet I'm not adding the regs thing properly in a few places. I am. Oh, wait, right L. Isn't this backwards? No, it is right. Val dart regs, yeah. Dart val regs, yeah. The problem is that these are asynchronous, so doesn't mean the problem happened there. It could be earlier. Probably one of these actually. Yeah, right. X. Yeah, that one's right. Ah, yes, this one's wrong, for example. Oh no, those are fine. That's the value. Those are fine. And those are regs. Yes. Yeah, those have regs added. Regs, those are added. Regs, those are added. Yes. 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 Regs. 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 Okay, those are fine. Let's see if that fixed anything. I should just use the hypervisor, but because at least will show me the problem. Actually, you know what? Yeah, let's just use the hypervisor. You don't trace SMC. You don't need that. It's been what, 10 hours? That's I think this is gonna work pretty soon. So let's be getting ready to get some dinner. Because I'm definitely gonna call it a day once Dart works. Yes. Lower sync. Oh, stage 1 transition failed. Okay, we have a totally random thing. Is this just the random Dart that I like completely messed up the address of? Did I just like completely screw up the PCIe Dart address? Six one 6810 0800. Oh, that is right. How did that end up not translating? It just translated in some funny way. 68 is just 68. It's not up, but oh, okay. I guess this is just an SR. Yeah. It shows up as translation failed. It's not translation failed. It's an actual SR probably. So let's disable that. Translation fault. Stream 1 code 4 no PMD for OVA at FFF8 blah blah blah. Cool thing is this is the hypervisor, so I can just instantiate it. This would be Dart DRD1. I think that's what it's called. No. Dart USB. And this is instance 0, I think. Everything is invalid. Why? I should trace that. $52F. Yeah, that should be enabled. It is enabled. Bold. Translate, enable. Why are all of them enabled, actually? Shouldn't it just be, like, one stream that's enabled? Oh, am I, like, not looking that up anywhere? Wait. Oh, no, TCR is there. TCR enabled, TCR regs, yes. Times 4 plus SID, yes. Yeah, it should be there. For each set bit, num streams. Maybe the bit set stuff didn't work? Let's print some more stuff. TCR, it's not next TTBR. That's wrong for one. That needs to change. Let's actually set up a macro for that because it's too messy. Wait, why is that even... Oh, because PM sleep is not enabled. That's why I built. Dart sit index. Something like that. But also, why isn't this working? I guess trace it. This is what now? Yeah, that didn't quite. Dart undeclared. This is in 562. Okay. Okay. Trace device. Dart USB 0. No, Dart USB 1 because it's the only one that we have. Okay. It didn't touch any of the TTBRs and stuff. So that sounds like the stream count is bad. No, 16 streams. That's fine. Isn't that mini? Did mini actually initialize that? I don't think it should though. No, it shouldn't. Um, Wait, it's still 80/20. This is like 80/20 stuff. So this is working fine. This is fine. This is the error code. Yeah, that was fine. No, this is fine. That's the clear of the errors. And it reads protect. Yeah, okay, that's fine. Yeah, this is the init. It's just not doing anything. Did I screw up the mapping or something? It should be set. Yeah, it's like literally not doing anything, and I don't know why. It does the init. Um, I think it's probably the SID thing is broken, so it never actually finds any SIDs. Isn't this backwards? Um, Hold on. I feel like I did something backwards. Um, yeah, search and domain from. from master. Yeah, and that's the sitmap num streams. We do have that. That should be rounded up. Yeah. Um. Hmm. Bitmap set, is that wrong? Wait, it didn't even do the enable streams though. So obviously that didn't work. Oh, wait. Am I doing that? Oh, because we do hardware reset before looking at the type. That's why. Yeah. Obviously we need to get the params first, calculate all this stuff, then reset. That would be part of the problem. Back in macOS. Oh, no faults. That's a good sign. Is USB going to work? Yeah, that happens. USB is switching to host mode. Hold on. The problem is that I need to keep a charger plugged in, and then I'm like running out of ports. It is switching to host mode at least. I can plug in a hub. I have a hub that has a PD input. Maybe that'll work. Yeah. Uh. What is that? 80? Oh, the command. Okay, it invalidated everything. It did enable everything. It cleared all the TTBRs. And then interestingly, nothing. It didn't actually... Is it in bypass mode? No. Oh, it's failing to start up. So I think but the interesting thing is that um it's also not faulting. Yeah, there's no there. Yeah, so it cleared it at least. And nothing mapped anything. So um I think it's probably just faulting because it's not enabled. But why is it not enabled? Why didn't it? Where's that NTTBRs from? Oh, okay, yeah, that's for like the number used, I guess. But yeah, it's not even getting called. Printf debugging. Actually, I can probably just get some stuff in here. Um. Oh, oops. Um. ABC setup trans. Okay, I guess the setup translation, so that's good. Um. That should be setting TTBR, but it's not. Um. You get the feeling that sitmap is not getting set properly. For semicolon. Did I add to the stream map? What do you mean? Um, Sitmap. It might be that part where I clear the bitmap and that doesn't work properly. Yeah, okay. It doesn't have any SIDs, yeah. Is bitmap set being used properly? Source post and bits. Yeah, that's right. You know, that is working. I don't understand the IMU API. Where is this actually? Attached device. Yeah, but that already gets the config from that. Oh, hold on. Is it because... bus ups get set after that gets initialized, so... You know, that happens afterwards. What about USB? Let's say the may C. What about the others? Here. USB. Yeah. Are you ever calling map pages? Where is sitmap getting... Master maps? Where's master maps coming from? Master config is the private. Oath translate, yeah. Sitbit. Okay, it just uses sitbit and clearbit, so there's no max issue there. dart detach dev. So now we have the master config. We do get that. That's dev AB. Let's just print that. Yeah, so it does map and unmap. Yeah, that is 0. It's calling clear bit. Why is it calling clear bit? Did I get these backwards? I think I... Hold on. Oh. Oh, it's not clear bit. It's... Ah. That's the problem. This should just be set bit. That's fine. Yeah, that would explain that. I assume that's initialized properly as, yeah, as 0, so it's fine. Okay, that's the bug. That is the bug. And now, of course, we're back in recovery mode. Okay, let's not print those. Those can go away because they are going to be very spammy. The others can stay. You don't have to bet that Apple software engineers are watching this stream. There's one in the chat. It's funny how everyone is like, everyone says that, and it's like, folks, we literally have some. Hey, still doesn't initialize. Oh, translation fault. Okay, we're back. So now something is happening now. Yes. Okay. So now it actually is doing stuff. Stream 1 on F8000. Code C0 though. That's weird. That's what? Axie error, Axie decode? What? Really? That sounds like the address is garbage. That sounds like I'm setting the page table entries wrong. All right. Aha. Yeah, for starters, something is very wrong there. A TTBR. That address is not right. I think I'm off by some bits on the TTBR. Because I bet I'm not using that. Yes. Because I need to shift it back up. Yeah, I'm not even using that. Offset 0. Oh, actually, I'm gonna do it differently. I'm gonna say um nah. Nah, I guess we can just do it like this. Yeah, that should work. Adder off. That's a hub. That's an Ethernet interface. That's an SD card reader. All part of the hub I just plugged in. USB works. USB totally works. Okay, I'm gonna remove the print case, and do some commits, and I think that is it for today. Um, I'm gonna tweet that also. Um, okay, there we go. That should be tweeted. Yeah. Let me just clean up the print case here. This is USB 3. Sorry, 2. Well, the controller is USB 3. The PHY still is USB 2, so that's why that doesn't work. But that should be the same, probably as on the other on the M1. So once that works, it should be fine. Yeah, like the actual USB 3 host is working. It's just the PHY issue, which is why we don't have USB 3 in general for any of the machines. But that shouldn't be different on the M2, I don't think. Sven, this is a MacBook. Yeah, USB 3 needs some PHY config stuff. And it needs everything, basically. Sven was working on that. My print K. Is there anything else there? Nope. Okay. Let's see if I can get this committed without it being a giant pain. Yeah, that. Well, that can go in later. So Dart. I guess the first thing is this is gonna be a giant change. So what I'm going to do is in HW we can put in the max sit count. I guess we don't need the brackets on that. Dart, num streams. Yep. I should have changed the right L there to. Also, I should use Dart TCR for that. It makes it a bit easier. Keep that. Go to regs. Yeah, we're gonna use the Dart TCR thing. This one we just want the bit set. Keep this one. Actually, yeah, just keep that one. And no parentheses, no brackets, braces. Here's TVR. Keep this one. This is very similar to what I did with AIC when I added support for AIC 2. Okay. So that should be the bitmap changes to support more streams. Oh, so those should be max hit count should be 16, not 32. Um, oh, TTBR shift. That one has to go back. Set TTBR. A line snuck in there. Git stash. Hmm? Oh. Wait. Oh, right. I stashed everything. Yeah. How do I do that? Oh, and that lost me the ad. I'm dumb. I should have committed that. Okay. Let's try that again. Yes. Max streams to 56. Not that. 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 Ah, that one should have been in there. Keep that line. Right, leave these two. And then just do that for now. Shouldn't there be a that there? Oh no, there shouldn't. I don't know. I can fix that in a bit. Split yes. No. No. Split. That one can stick at max TTBR. Okay. I think that one makes more sense. Yeah, I need to fix some stuff there, but let me commit that for now. Um, and then I need to do a few changes still that I missed. Mostly that. That one too, but just get 0 here. That one's fine. That one's fine. I think everything else is fine. Except for that one. And those invalidates, did they have the... Oh yeah, that one's also missing. Oh yeah, sit up 0 is missing there, yeah. Is already going back? Yeah, it's already undecided, so... That's fine. So the thing I missed. The thing I missed is that one. Everything else is fine. Okay. Amend that. Okay, now the TTBR thing. Actually, I kind of want to change the way I do that. Max TTBR. Let's do Dart TCR in here too. Dart SID. And then I can just use this here, and it'll be a little bit less ugly. Yeah. So the next thing I should do is a different number of TTBRs. Actually, I need to edit Dart TTBR to support that. Where's that? It is there, yeah. 16 times SID, 4 times index, yeah. Split that. No, 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 no. But this one. Okay, and now the TTBR count stuff. Just enable. Yeah, this part. Basically. No, this one's fine. This one I don't need. Oh, actually, yeah, only this needs to change because that needs to get a Dart in there. Dart regs, yeah. Oh, so that's just me not cleaning things up that I should. Okay, those are fine. Those are fine. Those are fine. Why is max sit count? Oh, no. Yeah, don't remove that. Just add another new line. TTVR count. And then that one, and those. Yes. Oh, that one's wrong. TTVR count 1 is it's 4 for T6000. Okay, let me fix that. Let me dart. Let me fix that. Should be 4. And I can the max sit count should not have had a space there. Amend that. And then this one, yeah, you should just not add that new line there. And then we have that string conflict. That should just be 16. Should also be 16 there. Updated upstream consumer space. Yeah, that's fine. Fine. Make sure this actually compiles. No. Dart TCR. There's no IDX in TCR. Why? Oh, SID, not IDX. Yeah. Okay. TCR. Dart TCR. I need to get rid of the stream map stuff here. Yeah, should be better now. That does have dart regs. Yeah, should be fine. Let's do the params page shift stuff. Um, oh, no, those are right. Yeah, page shift. That's fine. Not amend. That's S. Dart. Okay, now the stuff with the renaming all these registers. I did add streams enable. Yeah, that is actually needed. And now that should be. We don't need those braces. Starts it. Yep. So where did bypass 1 and 0 come from anyway? Were those the same? Bit 8 and 12, and I called those bypass. Yeah, dart and depth. So this is fine, except for the braces. Do I even use the Dart type anymore? Yes, only there though. Yeah, in only 2 places. Um. Hmm. I guess that doesn't work. That's annoying. Um. Yeah, because of the context or something. Um. Didn't I have this sit count at 32 in the end? Why does that not apply? Yeah. No, no. And yeah, this one I do want. But not these. Why? I did stage that. Um. Let me fix that at the end. Uh. And then I also need the. Yeah. Why did these not work? Format max sit count, and then we need these two. Queue handler, don't need that. Amend. Does that make at least the compile? It does not compile. Invalidate TLB because that didn't get added yet. Get stash show diff. How do I do that? I don't know how I do that. Oh, that. Yeah, these. Apple Dart HW. That should go before the page table format. At the top. Okay. RQ100 by TLV, yes. Oh, no. This one has to be for this one. Does that build? Invalid TLB. Why? Oh, because it needs the forward declaration for that one. Yeah, that's it. Slash apply. Stash changes. Find the streams on base. Yep. Okay, that's fine. And now. Actually, let me get rid of some junk first. No, that should not be deleted. Yeah, that one's fine. I think that's reasonable for a single commit now. Where am I? Okay, that should be clean now. Let me just fix those fix-ups. Yeah, parent of that. Yeah, well, we know that. Support 60, more than 64 stream IDs fix-up. Oh, that's just a fix-up. Go to apply. Yeah, the fix-up. Wait, that's before the user was set. Oh, that's kind of annoying. Hold on. I think I may have done something wrong there. Okay, that's not a fix-up for that. That's weird. um, the 5C, whatever. 5C41 should stay where it is. I don't know what that was. Let me just do that manually. No, that is max count 16. And then it's just a fix up for the wrong thing, is what it is. Continue. $66. And then this one is the one that's missing. Yeah, that was just a fix up for that one. And the 32 problem came in later. Yeah. That one's fine. I just need to fix the 16 that happened there. When did that sneak in? There. Okay. And now, if this builds and runs, I'll be happy. I think that's going to be the end of the stream if this runs. Optimistically pushing. Oh, come on. What did I break? Oh no, that's just PCIe. That's just the PCIe. Yes. Mini should be fine to push. Yeah, latencies. I can add that actually. Yay, works. Status cluster P state. Yes. Let's do the display stuff. I don't care about that. I do care about that, though. And now, yeah, this is good for now. I'm gonna just push that. Apparently I failed to fetch. That's really annoying. Yeah. Okay, that works. And Linux is done. So there you go. That's the end of the stream, and at a good time too, because I'm nearing 12 hours, and 12 hours is when YouTube decides to cut things off. So that was definitely the time to stop, and I need to get some food and get some sleep. Some picks up commits in mini, do I? Maybe I do. Didn't I rebase? No, I just rebased, so that should have been fixed. No, there's nothing there. I probably should have. Okay, that was good. No formatting problems. So yeah, that's that's all I got. I tweeted earlier so the things that are left to do are the keyboard and trackpad need a new driver for the low level interface. I get the feeling it's not going to be very hard, because I think if Apple did what I think they did, it's probably actually easier than the old SPI one. The only thing is that it might need RTKit startup, but we already have the code for that. So, then the what else? PCIe needs probably just those masks, the fuse bits that need to be read and written to the register. So there's this array basically. There's this thing here, PCIe these. I need this array from macOS basically, or an equivalent. And technically you can get that with a hypervisor, but it's kind of annoying to like you need to hook all the registers to figure out what the bit offsets are being read and written to. So, and you end up with the same data anyway. So it's easier to just look at it in the macOS driver. Other things, speakers might work. I haven't tested them. I'm not going to test them right now. Hopefully I haven't blown them. What else? Damn, I'm tired. What was it? SPMI needs a new driver. That'll make the PMU work, so that the RTC isn't working right now for that reason. And that's mostly it. I think once those things are done, it will be at feature parity with the M1 laptops. So there you go. What else? Oh yeah, I haven't tested running macOS yet on the hypervisor. Let's do that just for good measure, because it's fun. Yeah, that. Was it in there? Where did I put that? The kernel temp chickens. Yeah, that. Just for fun, let's just run macOS into the hypervisor. What could possibly go wrong? Mini run guest. Yeah, let's just do it. Oh, there's a warning there. I need to fix that. What just happened here? No, it is working. How's the Apple logo there? There you go. macOS running under the hypervisor. Works totally fine. Helps if I type my password in properly. There you go. I can trace, I don't know, USB. And maybe plug something in or unplug something. Well, I don't want to screw it up, so let's plug in like an SD card. Oh no, that was the Dart. Oh yeah, it is. Yeah, there you go. So it's doing some stuff with the Dart. Let's trace P Manager. I mean, that's gonna be very noisy. Yeah, P Manager is super noisy. So there you go. It all works. It's nice when things just work. Also, what was that CPU start thing? I think that oh, it's just oh, this should be returned. That's the only problem there. Yeah. Should be return on that. Just that. Where's the SMP? I'm just going to force push because I'm like that. Okay. There we go. Yes, Ridley, everyone, you're saying the same thing everyone says, that you went to sleep and woke up and yeah. Why weren't you I don't know why you weren't expecting this. You know how this goes. Anyway, yeah, time for me to get some sleep and some dinner and some stuff. Thanks for coming. I hope that was enjoyable. And yeah, not bad for one day, I would say, on the M2. So yeah, thanks for watching, and see you next time.